Cool. Can we start? Hi guys, everybody. Can you hear me all right? Yes, very good. My name is Paul. I'm with the Circles team, and it is my absolute pleasure to be doing this workshop together with you on a deep dive into the Circles protocol. So when I told Vanchika, our DevRel member, about my plan, she was like, well, you might not want to call this a technical deep dive because people would expect to be building hands-on stuff using SDKs and everything. So I'm sorry to disappoint. This is not going to be a sort of a builders workshop. Instead, Circles is a great protocol that we've been cooking up for a couple of years, but it's not the most intuitive and simple protocol to wrap your head around. So this hour is mostly about making sense of the protocol in terms of, why do we think the currency we've designed is sort of a reasonable currency and what it works towards. And I'm just going to keep talking a bit until the technicians have solved the issues with my slides. So maybe in terms of sort of setup, as soon as the slides go up, they're going to see a bunch of QR codes. So the first of them is linking you to an app called Mentimeter, where you can add questions that you have. And then everybody else can vote on these questions. So the idea is, I've been told that this is live streamed, and having lots of Q&A in between with the mic being handed around can be a bit sort of cumbersome, and then for the people watching online, they might miss out on questions. Plus, I think it's important, there's lots of questions, and we want to address those questions first or prioritize those that, most people find interesting. So I would suggest that questions of sort of immediate understanding in terms of just not getting something I said or something that is on the slides that doesn't make sense to you, I think raise your hands, wait for the mic, and then we can address that immediately. But if there's sort of bigger questions you have, or things you wanted to always kind of like, ask people from the Circles team about, then use the QR code, add them there, and then I'll have a look. So on top of that, I already added 2 questions that you can vote. One is, I think, called more detail, and the other is called less detail. And this is basically something that serves me to give me a kind of feedback whether I'm moving too fast or whether I'm moving too slow, right? So feel free to also participate and sort of upvote if either one of these 2, if you feel like I'm moving in too much detail or not. So this is the QR code in question, but you also see this code here at the top, right? 137302226, and you can go on menti.com and use this code. So the QR code is going to disappear in a sec, but the code isn't. All right, so removing this code thing. Also the first time I'm using this. Right. To get hands-on experience, it really helps having a Circles metric profile. So just to be clear, there's Circles the protocol, and V1 of the Circles protocol has been launched in 2020 already. And last October, we deployed the version 2 contracts of Circles. So the Circles protocol V2 that we're representing today has been live already for half a year or so. But what is only very recently launched is Metri. And Metri is a wallet that is sort of the go-to wallet to interact with the Circles protocol. We're going to see that it's not the only way of doing so. There's other tools that we've built, mostly first for internal use, and now we're sort of publishing them to interact with Circles. But it's kind of important conceptually to understand that there's this difference between Metri, the wallet, and Circles, the protocol. And yeah, if you don't yet have a Metri profile, I mean, who here, not shaming it, who has already a Circles or a Metri profile? So lots of people. That's great. That's great to hear. If you don't yet have one, downstairs we have the booth. After this talk, we can invite you, and then you can kind of get going with networking with people here. Scope of this hour we now have together. I'm one of the co-authors of the Circles white paper, so that's going to be something I want to talk about. Plus, I also want to present some of the tools we use to kind of inspect the state of the Circles network and kind of details you don't see when you just use the Metri app. What I won't be talking about is sort of the high-level motivation in terms of, you know, why we think the world needs circles. I'm going to kind of touch on that, but not really make it the focus. So for the purpose of this hour, we're just going to assume that circles is a great addition to the world, and we're just going to be interested in how it works, not so much why we need it. And what I'm also not going to be talking so much about is dev tooling, in the sense that, you know, if you wanted to build a Dapp on top of circles, how would you go about doing this? We have great docs at docs.aboutcircles.com, and I think one of our tech leads is going to have a workshop on this tomorrow. I don't know at what time. Yeah. All right, so this morning at 11, Martin, who is the CEO of Gnosis and also the kind of originator of the idea of circles, was gonna do a talk on circles. Now that got postponed, so for the sake of getting everybody up to speed, I'm first gonna start with a simple recap or sort of high-level intro to circles. So it begins by understanding that money is a technology. It's the world's most ubiquitous protocol. So we use it every day, and we think of it, the rules, as sort of something that maybe is sort of just set in stone or given to us, but that's not the case. It's a social technology, and it's a technology that isn't neutral. If you're in control of deciding who gets to create money under what conditions, and kind of hand that technology to whom, then you can have a lot of impact on terms of, sort of real economic development. So we can think about, given the tech stack of the blockchain and all the other great things that we now have at our fingertips, how should money work in a way that we think it would be fair? So I think Martin sort of sat down, at least in this sort of ex post constructed thought experiment, he kind of sat down one morning and he thought about how can we build money that works better in a multipolar world where we don't want to necessarily rely on, you know, the US dollar as the main reserve currency. But instead, we want to have a currency that is unaligned, that is universally accessible in the sense that everybody can go and create their account, regardless of, you know, their passport or anything, that splits or that democratizes access to the technology, which is money creation, and lets everybody benefit from the technology, and where also we don't have sort of the first mover's advantage in the sense that, you know, the first of two generations of people doing this are going to run away with the bulk of the value, and then, you know, sort of everybody else misses out. So we want to somehow have fair access to the money across time, meaning across generations of people. And Circles is sort of the one answer to this design challenge. So it's unaligned in the sense that it's a completely unpegged fiat token. It's not a stable coin, and it's not representing the interests of any particular entity. I mean, that is to be taken with a caveat. Of course, right now, Gnosis is a big sort of stakeholder in the currency from the point of view of, you know, kind of funding the development, etc. But Gnosis isn't hard-coded into the protocol. The contracts are open source out there, and they could be deployed on any other chain right now, right? And we don't have, as a team, we don't have any say in what people do with this currency. Yeah, it's universally accessible in the sense that everybody can create an account. We don't have a KYC layer or anything like that on top. It's democratized in the sense that every user can create their own personal CSC token at a fixed rate of 1 circle per hour. And fair access across time is ensured by having sort of this funny counterintuitive property of demurrage, which is a kind of daily burn. So all circles balances evaporate at a rate of 7% per year on a daily basis. And we can look at how, you know, how this leads to this fair access across time. There's an additional layer of complexity to circles, and I quickly want to talk about why it is there. So Circles' intention is to enable every person to create 1 circle per hour unconditionally. Not more, not less. And we have this problem where does this have a pointer? Oh, but I'm not. Anyway, sorry. Yeah. You know, so we want to allow anybody to create an account, we want every account to start creating their own money, and we also want sound tokenomics, which is sort of a bit of a mouthful. By this, I just mean we want there to be one circle per person per hour. Now, of course, how are we going to deal with Sybil attacks? How are we going to keep people from creating several accounts? And if Evgeny here created secretly 10 accounts, he would make 10 times as much money every hour as I do, so he could buy 10 times as much coffee as I can. And so if I know that he's able to do that, then why would I use this currency? So if lack of confidence in the ability of the protocol to produce sound tokenomics, in the sense I define here, would of course be detrimental. So to safeguard against Sybil attacks or people kind of exploiting this protocol, or the openness of the protocol, we have a web of trust approach. What this means is people on circles who have an account can trust each other, and this is a binary relation that is simply sort of registered on chain. And then there's the rule of trust. And the rule of trust basically says this: if Alice trusts Bob, then anyone in the network holding circles created by Bob circles, can swap them at any time for any circles held by Alice at a rate 1-to-1. So in this example, we have Alice here holding her own circles, and Bob, and Alice trusts Bob. And now Carol, who happens to hold Bob's circles, can go in and, without Alice approving this, kind of sign a transaction that lets her grab the 5 circles from Alice, and in return for 5 Bob circles, resulting in this final state where now Carol has the 5 Alice circles, and Alice is left with the 5 Bob circles. And this actually is independent of these being Alice circles. Like if Alice held Dave's circles or Paul's circles, she could still be doing that, right? And so this rule of trust is interesting in the sense that it lets disconnected circles users transact while ensuring that everyone only ever receives circles they trust. So in this example, we have Dave, who wants to send Bob 5 circles. But Bob doesn't trust Dave. So Dave cannot go and take 5 of his circles and hand them to Bob in exchange for a cup of coffee, because Bob's going to say, no, I don't know you. Who are you? I'm not going to give you anything for your circles. However, Bob knows Alice and trusts her, and Alice happens to know Carol and trusts her, and then Carol knows Dave. So there's this path of trust. And the existence of this path of trust, together with this rule, this swapping rule, lets now Dave initiate a sequence of trades where he'll first get 5 Carol circles for his Dave circles. He'll then use those 5 Carol circles to get his hands on 5 Alice circles, and then he'll send those 5 Alice circles to Bob, who now is going to say, well, Alice circles, that's different. I'm going to give you coffee for Alice circles. Right? So this is how the rule of trust enables transitive paths of exchange. And we're going to talk about how this now is meant to sort of safeguard against Sybil attacks in a second, or in a couple of minutes actually. But just to kind of close this brief overview, there's an additional feature that we probably want to talk about as well, which is groups. So groups weren't a thing in the V1 protocol. And groups are essentially accounts that don't create their own circles at a fixed rate of 1 circle per hour, but they have members. So they can make other circles accounts members, and then there's a mechanism for how these members, or people who hold those members' circles, can exchange them, can kind of turn them into group circles. And we think groups are a really interesting mechanism and vehicle, but I'll talk about them in depth later. Right, 8 questions already. I'm going to check can somebody tell me whether there's a lot of votes for move faster, move slower? So I don't have to mess with the... Okay, take your time. I mean, if anybody, maybe Sean, you can tell me if people are screaming I should be speeding up or something. All right, so this is the beginning of the deep dive. Right now, we're just sort of swimming at the top, learning how to swim. Now we're kind of going deep. So, and to do so, I kind of want to structure this in 2 sort of stages. And by the way, I plan to talk in total like 35 minutes. So I want to leave 25 minutes or so for Q&A and discussion, right? I'm not going to be talking like this for an hour. By 6 votes. Okay. Right, let me just create some extra slides. I was expecting the opposite, but yeah. Okay, then I'll take more time, and yeah, I don't really have an actionable way to. I'm just going to talk a little bit more. But so, yeah, here's more detail. There's the macro level and there's the micro level. It really helps me to think about this apparent complexity of circles and break it down. So the macro level is the level at which we assume that all people that have a Circles account are honest. There's no Sibyls, right? And we're interested in the kind of macroeconomics of Circles. Circles has kind of counterintuitive rules, right? There's demurrage, there's constant issuance. It looks very different from money as we know it. So how would a world look like in which there was this Circles currency? And we don't want to deal with the web of trust. We don't want to deal with Sibyls. We just ignore all of that. So that's the macro level. And here we kind of just see users who have different Circles balances. And we assume that they're sort of fully liquid with each other. And then the micro level is the one where we kind of drop that assumption, and we now start differentiating between the different kinds of Circles they hold and who created them, and we also drop the assumption that all accounts are kind of honest or kind of use the protocol as intended. And this is going to be sort of the micro level where we deal with the web of trust and pathfinding and so on. So, right, let's start with the macro level. So assumption, no malicious parties, or fake accounts. And the first thing we can think about is, well, how would the balance of a single account look like over time, right? Because there's 2 forces in Circles. There's the force of me creating 1 circle every hour, and then there's the force of 7% of these circles evaporating over time. So the way this looks like is that if I started creating circles on day 0, and I just did this every day, every hour, I kind of used my Metri account. Or in fact, we didn't talk about Metri fees, but if there were no Metri fees, I would use Metri to create circles. And then over time, initially, my 1 circle per hour rate dominates these 7%. So I kind of quickly increase my circles. And then over time, those 7% kick in because I have more, so I lose more. So because those 7% of more is more, I guess. And so there's this magical number of 120,804 where these 2 forces exactly cancel out. And so if after 80 years I was to die and to stop pushing that button, this is how the total supply of circles I created would look like, right? And, well, why is that interesting? Well, first of all, Circles has this super simplistic base monetary policy, which is that the total supply of CRC in a group always converges to that magic number times the number of people in the economy, right? So we kind of naturally scale the supply of the currency with the number of the people. We don't have an interest rate, we don't have, a lot of the sophistication of the Fed, but we have this. Another way to look at this is that, I guess the vote now deals with this, but there's sort of an effective tax rate. So if you have exactly 120K, 804 circles, then your balance just remains unchanged. Whereas if you held more, then your circles balance would reduce, like in the absence of transaction and economic activity, right? And so this is sort of you're paying that tax. Although, I don't really like calling it a tax because it's not, nobody receives that tax. It's not like Metri or Gnosis gets the circles you burn, they're just literally burned. Whereas if you just start out, then you have this negative tax because, well, you get a lot more than you started out with. And here's why we think that the combination of this steady issuance rate together with the 7% demurrage leads to fair access to money supply. So there are 2 types of fair access, right? There's the fair access at any given time, which is just to say that nobody has a monopoly over money creation. Like the creation of the new supply of money is completely distributed uniformly across the whole user base, right? So it's sort of fair in that sense, I guess, depending on your notion of fairness, but I think that sounds pretty fair to me. And then there's this more interesting fairness over time. And to appreciate that, consider a user that joins an existing group of N people. Like, we now have a circles economy, and we all start creating our circles like crazy. And then in 2 years, somebody comes, and they consider joining this group, just like lots of people might today consider buying their first Bitcoin. And we want to give them a good reason to join, right? And with Bitcoin, I mean, I'm not going to hate on Bitcoin, whatever, but like the idea is it's not very attractive to join now if you look at the distribution of the existing supply. When there's so few people that hold so much of the supply of Bitcoin that's ever going to be around, then they are in a position to go into any shop and pay whatever they want for this cup of coffee. So do I want to be part of a society where my ability to buy coffee is basically dependent on other people's desires? Well, okay. No is the answer, of course. I won't let them do that to me. Instead, I'm going to use circles, because the combination of demurrage, of this burn, and constant issuance says that if somebody joins later, then the share of the circles that they have created, that they contributed, as a function, like as the share in the total supply, is going to look like this, where capital N here is the size of the group, so maybe like 50 in the example of this room, and this gamma constant is a constant that kind of goes to zero exponentially quickly in the number of years that they've participated. And so 1 over n is obviously their share in the group, right? So this means whenever I start, if Circles was to become the next global currency, if it's just a tiny experiment, it doesn't matter at all. If I start joining, I have a guarantee that I will start building up a significant share of the total supply, like a significant share of the total supply of Circles is going to be under my name. It's going to be ones I have created. And they, of course, go into my pocket, and I can invest them, I can spend them, but nobody else can decide what the purchasing power of me is going to be in that society. So that's what we mean by fair access to money supply over time. Oh yeah, I have a slide on this. All right, and there's, of course, in the white paper we talk about time-varying populations, and of course that doesn't change the gist of this statement. Another thing I want to talk about I think I need to speed up. At the macro level is the value of seigniorage. And what does that mean? So Circles V1 was kind of marketed as a UBI, and lots of people think of Circles as a kind of UBI, which of course makes sense because we kind of airdrop money into everybody's pockets. But the sad truth is that the value of the circles that you're going to be creating over a month is probably not going to pay what you'd want a UBI to cover in terms of your monthly expenses. It's going to be a much smaller share of this. So seigniorage here is basically defined as, it's typically defined as the revenue that the government makes from the issuance of currency. It's this sort of value creation of thin air example where if you print a dollar note but you only paid 1 cent for it, then you have sort of 99% profits, right? 99 cents profit. And that's the seigniorage. And of course you can have seigniorage also when you hand out credits, so this isn't really about cash only. And in Circles, of course, the seigniorage is with everybody. We democratized access to money creation technology, so we also democratize and distribute the benefits of that. So the question is, well, what do we expect the value of the Circles created by an individual to be? And there are 2 approaches to answering this question. One has been conducted by Martin in a blog post, where he basically looked at different economies, and he looked at the current total money supply, the M2 supply. He looked at the population and the GDP, and he basically said, well, if we have so and so many million people, and we take this times 120, 804, right? This magic number. And then we look at the total money supply, then we can kind of like take the ratio, and then depending on stuff like velocity, we can cook up a hypothetical value of one circle in equilibrium. It's like if Circles was to take over the world and completely replace the USD, what would kind of the circle, like what would one circle have to be valued at to kind of cover the same GDP? And so this is like, these numbers here range wildly. So they're like 30 cents, like 50 cents, 50 cents. So this is sort of gives you roughly an intuition, right, where you would expect Circles to land at if it was to become really successful. And this is not like 100K, right, per circle. This is clearly very low, but much higher than it is now. I think today Circles trades at like 1.5 to 2 cents. And there's another approach, which basically, well, looks at the fraction of the value of Circles created at a time t divided by the demand, and so it kind of just looks at, kind of what if this currency was at equilibrium, what if there was enough Circles to cover the demand, blah, blah, blah. You can look up at the appendix, and then you get to this number here, where this is the velocity of money, which we can set to 1. And if we look at like the euro, for example. And so what basically this says, if I translate it, is that we would expect the total value of the Circles you create per month to constitute roughly 7 to 10% of your demand for money every month, right? So if you have monthly expenses of 2,000 euros, that on average, it takes 7% of that, and that should be roughly the value. So these two approaches, they kind of roughly align. They're not completely, don't give you completely different numbers. So maybe the value, like in today's prices, you'd be looking at $200 to $400 of purchasing power over the course of a month. So Circles is not a fully fledged UBI, right? Because for a UBI, we'd want maybe 50%, 40% of your expenses to be covered, or even more. I'm not an expert on UBI, actually. But they should constitute a significant source of income, and those Circles that you create, you could, of course, spend them on stuff, right? But you can also start investing them, because there's going to be financial products built on Circles. And so the hope is that, this democratization of money creation technology could lead to sort of allow mass access to interest-bearing products with the hope of kind of distributing the benefits of participating in a kind of a growing economy among sort of more of the population. And of course, it could also kill sort of extreme poverty, right? Where if people that were living on the street or something, $200 a month of things they could buy, that's a very significant amount. All right, there's a bunch more things that we cover in the macro level, but I guess you're all here for the graphs, so you don't really care. So let's move on to the micro level. So yeah, now we kind of turn into sort of switch on paranoia mode, and we don't trust anybody here unless they sell me an ice cream or something, I don't know. Yeah, let's maybe look at this. 15 questions, okay. Yeah, so first things first, the possible flow of Circles in this graph depends on both the trust graph and the current balances. So when we usually introduce Circles, we always make it seem as if there's just this path of trust, and then everybody can pay each other along the path. But that's simplified depiction of reality. What matters is who holds which Circles. And only if you give me the trust graph and the current balances, can I calculate, what's the possible movement, the flow of Circles in the economy. And that is simply because of this word any here, right? So I told you that it doesn't matter whether Alice holds Alice Circles or Dave Circles or Paul Circles. The rule of trust lets Carol take any circles she might hold. So we need to know exactly which circles she holds to calculate the implications of this rule of trust. Yeah, so usually we say, the state consists of kind of the trust graph and the matrix of balances, if you will. And then we can think about the state transitions that are possible. And these state transitions you always have to kind of think of relative to the signer, right? So clearly I can initiate or trigger state transitions that others cannot, because I can send my circles to Sean, but Sean cannot send my circles to him, right? So state transitions are always relative to the party that initiates them. But I'm not going to go into a lot of the technical setup and the formalization. What is important is that transacting in circles boils down to the following problem. What is the maximum amount of circles that the sender can pull together by applying this rule of trust, right, that are trusted by the receiver? That's the sort of transferable trusted balance. So I might hold 10,000 circles if I can only use this rule of trust to get 10 circles that Sandipan trusts, then I can only pay him 10 circles. It doesn't matter how many circles I hold. And we can actually map this problem to a well-known combinatorial optimization problem, which is called the max flow problem. And so, Hugo is our internal, maestro of max flow problems. And whenever you pull out your metric account and you send circles around, Hugo's algorithms are crunching the numbers for you. The max flow problem is actually, it's a complicated problem, but it's not an NP-hard problem. So I think it's kind of famously polynomial in the sense that it scales, the complexity scales quadratically in the size of the instance. And I think 2 years ago, Google published something where they actually have sort of a quasi-linear time algorithm for MaxFlow. So MaxFlow is not, if it was an NP-hard problem, we should just throw circles out of the window. Because then, we couldn't scale just from the combinatorial nature of it. So luckily it isn't, and we have that. And let's talk about more of this if you're interested. Yeah, okay. So now we're at the point where we can talk about how this web of trust leads to Sybil resistance. And so now, using this mapping of the sending circles around to a max flow problem, and then using the famous max flow min-cut theorem, which you can look up on Wikipedia, we can basically make the following kind of statement, which we call relative Sybil resistance. So let there be some set of accounts that are controlled by a malicious party, and let F be a set of accounts that are fooled into trusting these malicious accounts. So they're fooled to trust people that they shouldn't have trusted and that we shouldn't let into the economy. And then let R be the remainder of the network. Then if these malicious accounts initially hold only their own funds, right, which is always going to be the case initially because they can only create their own funds, then the transferable trusted balance, like the amount of circles that the malicious accounts can transfer into the remainder, is limited by the amount of circles that are trusted by accounts in R that are held by accounts in F, whatever. Like, if you look at the white paper, I'm not going to introduce the notation here, but basically what we're saying is that this is the thing we want to have very small. This is the amount of circles that malicious people can pull together and spend in the sort of the honest part of the economy. So ideally, we want this to be 0. And we can bound this by this thing, which is independent. All you have to know is that M isn't in this formula. This is now the amount of circles that the fooled people hold that are trusted by R, by the rest. So what that means graphically is that here we have the malicious people, here we have the fooled people, and here we have the remainder. And the remainder is exposed to the malicious accounts only to the extent that these accounts, who sort of have been fooled, hold circles that they trust. And so this is sort of the damage is independent of how many circles the malicious people hold. It's only limited by the size of the leak. And importantly, this leak will kind of close itself, because if these people hold significant resources like circles that they trust, then they can kind of use that, but that will reduce. Like the damage is sort of bound by what they initially hold, and it sort of leaks close themselves. So that's our relative Sybil resistance property. I guess if we had a perfect proof of personhood and we wouldn't need the web of trust, then we might be even safer. But of course, it's also difficult to build. I mean, we know that there's a lot of other protocols that are also trying to build sort of a proof of personhood that are struggling. And because this is sort of the Achilles heel of the protocol is if people fall prey for malicious accounts, then we have a problem with circles. And that's why we trust in the wisdom of the crowd to not fall prey. That's sort of an important point. Okay, before I finish, emergence of global fungibility. So fundamentally, we not only want to exclude Sybils, we also want the honest part of the network to be liquid with each other, right? So I mean, sort of, we're gonna want two things. We want the honest people not to have exposure to the bad people, and we want the good people to be able to pay each other, right? If I have a super Sybil resistant network, but every time I want to buy coffee, I cannot because there's no path, then I also haven't built a very successful currency protocol. So we can measure this by the average spendable fraction. Like if we have this honest part of the network, how much are people going to be able to pay each other relative to their current circles balances? And so we can look at different graphs and the kind of average spendable fraction that we get here. And so if we had, for example, a complete graph where everybody trusted everybody else, then it's easy to see and kind of intuitive that independent of the balances of these people, they can all pay each other, right? If any one of them is offering services for anybody else, they can kind of interact like they do with euros, right? Like always 100% of the circles they hold, they can spend with others because there's always going to be paths. But importantly, like crucially for circles, the same holds true, albeit less robustly so, in a setup where everybody's connected with everybody else, and there's always a path. And in this case, you can also have complete average spendability, but it might sort of die down. Like so, you might be able to do this once, but you might not be able to keep it up. And so, yeah, I'm kind of speeding up a bit because I want to leave time for questions. But the end goal, or like one goal, is of course for circles to become sort of a big global currency where there'll just be one price for circles, and we can all forget about this micro-level detail of who created what, because we trust in the web of trust doing its thing with respect to keeping the Sybils out, and we just sort of enjoy the ice cream we can buy, and we don't really have to deal with the complexity. And that will depend on people's behavior and the connectivity properties of the trust graph. And so whether that will happen will depend on user behavior, but the hope is that kind of the trust network inherits the small world properties of social networks, right? Which kind of famously have high connectivity despite being sort of pretty sparse. And that is to be seen. That depends, and I don't want to sort of spend too much time here. There is one slide I have here on exchange rates and arbitrage that people find arbitrage for some reason always very exciting. I don't really know why. Of course, all these circles, everybody creates their own circles, and you can create a market for them. Nobody can stop you from doing that. So there's an obvious question. All of us have their different circles. What do we know about the equilibrium, like the fair prices of these different tokens that we now have on the dexes? And I think there's a simple statement here to kind of develop an intuition for this, which is that for any state in which every account holds some of their own currency, right? And that's sort of pretty likely because, well, you create one every hour, or you can. Then exchange rate, in the absence of arbitrage, reflect the trust connections between users. So if n trusts n prime, then the price of n prime, the one that's being trusted, has to be at least as high as the one that you trust, right? So trusting everybody, like, I mean, this is a bit of a sad statement, but trusting other people can never increase your exchange, your equilibrium exchange rate. But being trusted can also never decrease it, right? If it was different, then we'd be also talking about sort of a rubbish currency, because I could build a bot that trusts everybody and then just lift my price, right? That obviously can't work. So we in the Circles team, we build arbitrage bots that are constantly looking out for these opportunities and try to keep all the prices in check. And if we have time, we can look into that. Oh man, I don't have to, yeah, I'm just, so we have this really exciting feature called groups. And this is a depiction of the trust mechanism. But let me just finish here. And then if you really want to talk about groups, we can talk about them, but I kind of really want to start looking at the tools. I've already talked way longer than I wanted. So there's, of course, Metri, which is the app we're building that I think many of you are using to interface with the protocol. But there are a bunch of other tools, and I want to kind of highlight some of these here. So the Circles Explorer is kind of the Explorer, kind of like you know it from Gnosis Scan or Etherscan. The Circles Core app is an app that we built for admins of groups and organizations to deal with members. It lets you create new groups. And the Circles Tools is a bunch of informal tools that we use most internally, but that all of you are also kind of invited to check out. This is a QR code for the Circles Tools. And yeah, I mean, my plan was to kind of like accompany a lot of my talking with real exploration, but I think now is a good time to actually just start looking at the questions. More detail. Why would you back your circles? Yeah, very good. Can I order them by, see all questions? Okay, I think these are already ordered. So let's take a deep breath and go through them. So do all of you know what backing your circles means? Okay, who doesn't know what backing your circles means? Okay, good. So backing a circle is not part of the core protocol, but it's something that we offer people to do on Metri. And it basically means investing $100 and and now, so workshop dummy Alice is not a backer yet, but I, for example, am. So it lets you back your individual circles with 100 USD, and what we do is we create a pool on Balancer with 48 of your circles against $100. Well, I mean, I think the main reason for backing your circles is, I guess, ideological, right? I mean, so it's a way of signaling that you support the protocol and you buy into the idea of circles. When you back, you get a nice backers badge, and there's a group of backers that is exclusively available to you. Also on the Metri app, you only when you back will you be able to swap your circles. So for example, it's here. This circles don't show here, but if I sort of log out and I log in with my main account. So all of these circles accounts, they're clearly marked as test accounts or dummy accounts if they're not from AB. You see, I have this backers badge here. So you now, because I'm a backer here, when I go in the wallet, I can swap circles. It shows them here, and that's. I mean, there might be sort of economical reasons for doing it, but primarily right now we think that just like a central bank has a reserve, we now kind of democratize the central bank and we split it up, and some of the people sort of constitute the reserve, and by backing you contribute to the reserve of circles. And of course, the more people contribute, the better, the more of an argument we have when we go out to people. So if I was to go somewhere and say, please accept my circles, then being able to tell them that they can now, if they wanted to sell those circles and turn them into cents or euros on the market, that's a great argument to give somebody. Right. So results. Yeah. What's to stop flight of capital when people get nearer to that amount where someone might prefer to have a currency which is or even more fungible but decays at a slower rate like regular fiat? I don't understand the question.
I think it's about, can you avoid demurrage by swapping to another currency? No. I mean, you mean another Circles currency or No,
USD?
just shown a swap interface with non-circle currencies. So
Yeah.
I could just swap to another currency to avoid demurrage and always keep my balance in a non-circle currency mostly.
But how would that keep you from suffering from demurrage?
Well, once I have the dollars, they don't demurrage.
Yeah. Sorry, yeah, the microphone. I forgot about the microphones. Well, I mean, so all that demurrage is that, all these circles nominally disappear. And so, of course, the total supply of these circles affects the price, but I don't think sort of the prices of circles on the market reflect that supply. So I just don't see a specific strategy for how you would be able to deal with demurrage or like trick it. But maybe I'm missing something.
Actually, I think it would be reasonable.
Sorry.
It would be reasonable once you reach the plateau to keep your circle level below. That's the idea behind this question. Yeah, so that you never lose more circles than your daily amount you gain. We are 80 years in the future now, but once we get there, I think many people will do that. Sure.
So you're saying that we're in this world, everybody has 804 circles, and now they sell their circles,
change for something else, yes.
And then they get them back, and then they buy them again, and then, I mean, if you have a sort of very specific I don't see how this would let you gain an advantage. I don't see the sort of arbitrage opportunity in doing that, because of course, the demurrage, the prices factor in the existence of demurrage. So I would be curious to see a specific strategy to do that. I don't see it off the top of my head. There's a question down here.
Is the balance in the liquidity pool of circles also demurraged, or just in the wallet?
Yes and no. So what happens, the circles you create, they're all ERC 1155 tokens. And the contracts apply the demurrage in the sense that if you check somebody's balance, they factor in the number of days that have passed, and then they subtract that. On the market, we have ERC20 tokens. So you first sort of wrap your ERC 1155 into ERC20 tokens, and then those are the ones that you buy and sell. And that exchange, like when you wrap them, that's not a one-to-one exchange, right? And of course, the ERC20 token, the balances, they are static, right? So in the pool, your tokens don't suffer from demurrage. But the way it works is that the if I have 100 circles and I wrap them into ERC20, and then a year later I would unwrap them, then they would only turn out to be 93 ERC 1155 circles. So I quickly, I'm gonna look at the questions, but sorry for talking so much. I wanted to quickly also make sure I at least show you these tools because we only have 10 minutes left. So this is the first of the 3 links I showed you, and these are these sort of informal circles tools. So you can, for example, have a group checker, where if you type in, you can look for any group, you can put it in here, and let's look at, for example, at the DappCon group. So maybe let's kind of get rid of the other complexity. And so every group has an address, an owner, a fee collection. This group, probably a price should pop up in a second, but I can kind of check the price of this token right now, and I can see the address, and I see a bunch of helper organizations that are also helpful. And in particular, this group actually has a membership condition, so there's sort of a smart module that checks that people who are added to this group are actually human avatars only, right? So no group or organization could be added to the group, and we enforce this with this membership condition. And now I can kind of swap, I don't know, like, I mean, this is not a very liquid group, unfortunately. But if I was to, for example, go back and we have this metric core group, for example, here, where is it, the metric core group, then this is more liquid, and I can kind of like see what I could get. So this is the group checker. There's a group creator. There's a tool for group management. There's a profile checker. Some things that are really quite nice. For example, this a Pathfinder Pro app here, which is a way to look at these paths. So let's see if, sorry. So this is Martin's account. I'm going to look for my main circles account here. So if Martin wanted to send me, 1 million circles or something, then, oh well, we can look at the graph here, right? So this is why I consider Hugo a magician, because he kind of like, while standing there, immediately tells me what the path should be like between us, and then I can actually say, look, I actually want to be paid only in my tokens, and this is going to reduce the graph. And so this is a very helpful tool to let you deal with these paths, and actually you can then execute them directly. So this app is going to give you also copy the call data, and I could kind of like go and execute this transaction directly. And Hugo's added a bunch of very, very fancy stuff in terms of path statistics. So this is a really, really interesting app as well. We have an equilibration analysis, which is kind of like a tool that looks at how well the arbitrage bots that we're running are at equilibrating the prices. And so this is not a good sign. I mean, we don't use red for good. We use red for bad. And so, but I always can just kind of like make a bunch of things green, but not that green. Right, there's a bunch of interesting tools here to help people. Also, if you have a group and you want to start putting liquidity against it, this is one thing you could do. Then, of course, there's the Explorer, which I can kind of like give it my circles account, and then it lets me inspect my trust relations and what I've been doing and my trust graph. And app.about circles is interesting because if I have groups or organizations, I can manage them from here. So for example, we have the DappCon group. I happen to be one of the admins for the group, so I could now kind of add people to the DappCon group. If any of you is keen on being added, let me know. We can talk about it. No, we all qualify. So sorry, I just quickly wanted to tell you about these things because I wanted to make an interactive workshop where we constantly use these tools to like explore the beauty of circles, and I ended up just talking a lot. Let's move back to the questions. All right. we've seen some cases where circles get stuck along the trust graph. Why does this happen, and how can you avoid it? So this is a real problem. We have had, I mean, I guess we've suffered from this as well. I think the mental model I have of this process is if you have a circles network where there's sort of points of high demand, then they kind of suck in circles into that direction. And this might lead to a situation where you genuinely don't, people have your circles and you can't get them back. And so people have been shocked to find out, where have my circles gone? I mean, all of a sudden, they're they care a lot about their circles, when 2 days ago they didn't care about creating a Metri account for months, but all of a sudden it's very important to them to have their circles back. And this is to be expected. I mean, this is the implication of the rule of trust, right? We go around, and if we trust everybody, then lots of people can take our circles from us, and if that is not a bilateral decision, then we won't get our circles back. So think twice before you trust somebody. Only trust people who you'd be happy to kind of like have a lot of their circles in your wallet. But that said, it's not just an implication of the protocol, because we've only had a bunch of small groups that we sell offers for in circles, and only very few people in the network have been members of this group, right? We have like a couple of thousand members, but only a couple of hundred of them had been in this group. The members of this group suffered disproportionately from sort of loss of their own circles, because their circles were in a lot of demand. So we have a job as the team to kind of be mindful about how we distribute demand for different kind of circles across the network. But this is the effect that you've seen. 2 minutes. I mean, I would probably suggest that those of you who, because we don't have, right? I think I feel like going through this is not going to be the right thing to do. So let me just kind of basically stop here. And those of you who still want to discuss questions with me, let's find a spot where there's oxygen and discuss them. I'm really happy to. I don't want to sort of shy away from any tough questions in there. But I think it's important that we finish in time and give everybody the chance to check out all the other cool stuff that's happening. So please create a Metri account if you haven't yet. Please run around, look for trustworthy people to trust. Get in touch with me or anybody from the Circles team if you have questions still. Martin's going to give a talk tomorrow. Daniel, raise your hand maybe. Daniel, he's our tech lead. He's going to give a workshop on the sponsor, like at the where all the booths are in the corner, I think, tomorrow, on all of the things I didn't touch on, like SDK, building stuff. There's going to be sort of a Sybil hunt. So that's very exciting. I'm going to give a talk on the Web of Trust on Wednesday on the main stage. And yeah, thank you all for being here, and enjoy Circles.
Can we get started? Hello. Great. Slides are working. Awesome. Hello, everybody. My name is Tino. I'm from the Hopper team, and today I want to show you how you can get started with the current version, the POC of Gnosis VPN. Set it up on your laptop if you're willing to follow my lead here. Otherwise, just look at what I'm doing. It's going to be an interactive session, and ultimately get a working VPN connection through the Hopper network going. So again, this is an interactive session, so I will have some practical steps where I need to sit down and show you some terminal interaction. If you want to follow along, there's a couple of tools which you will need to have installed. So make sure you have internet connectivity. Depending on whether you're on Linux or Mac OS, you need some different tools installed, so make sure you do that while I'm talking. And then you could follow this step-by-step process. You will need a Hopper node to use the Gnosis VPN. We have a couple of demo nodes prepared for you, so if you need access, if you don't have your own Hopper node, then there's my colleague around here somewhere who has handouts. So just Michael here, get a handout from Michael. It has the connection info for Hopper nodes, which you can use to get your VPN connection going. Okay, very rough. I will give you an overview of what Gnosis VPN actually is. If you are interested in that, you can also on Wednesday see another talk by Sebastian Bergel about the Gnosis VPN. I will give you some very high-level information of what the Hopper network does. That's important to understand because it's an integral part of Gnosis VPN. And then we'll go into setting up the VPN on the laptop. Afterwards, I'll give you a little bit of an outlook, what's coming next for the product, and then Q&A. Hopefully, there's some questions. Okay, so everybody here has probably used a VPN. Let's have a show of hands. Who has used a VPN in the last year or so? Okay, everybody, great. Who is using more than one VPN? Okay, half of the room. Who has built their own private VPN for their personal use or maybe friends and family? Awesome. At least one person. Well, as you then know, you're very privacy conscious already, having used VPNs and multiple VPNs. But the general VPN architecture in the market, by the way, this is a $50 billion market we're talking about, is counterproductive in terms of increasing privacy. It's meant for you to tunnel all of your internet activity through single servers, trusting a single provider, a VPN provider, which is a company somewhere you might not even want a relationship with. So it relies on you having a lot of trust in a single company, a single server, to do its job and not harvest the data you're pushing through. In my opinion, this is not the right way to do it, and that's why we are building Gnosis VPN to improve the state of art in this massive industry and improve the general privacy consumers can expect. So that's the reason why we build Gnosis VPN. We want to remove trust from the equation. As a VPN user, you shouldn't have to trust anybody really, because what you want is a safer internet browsing experience and not handing over your data to a company which you have full trust in. Communication is not private right now, and we want to really make it private. On a very high level, this is trustlessness in a nutshell, right? So the VPN itself should be trustless. It's also decentralized. As you will see, there's a fundamental layer of the Hopper network, which is a peer-to-peer network consisting of many nodes, so there's never a single server you have to work with. And also, it should be censorship resistant because the internet, as you know, has a lot of parts which might be blocked based on your geolocation or not, and a VPN should actually allow you to get past censorship like that. We are right now, product-wise, in the POC stage, so proof of concept, and as you will see, it's very technical still. You have to use the terminal, so bash shell, and obviously this is going to improve over time. But that's also the reason why this is a technical workshop, so bear with me there. The funding for this product development is coming from the Gnosis DAO. We've had 2 GIPs, one which was already completed, that's GIP 98, and one, the more recent one, is GIP 122, and that covers the development to make this an end consumer product. So moving from highly technical, low level, only developer orientation to being an end consumer product, having UI, a desktop app. If you're interested in that, check out the forum, the GIP, and the details which we've outlined for that. Okay, how do we move from this super centralized single servers, single trust relationship and architecture to something which is more meaningful? What we are doing is we are putting the Hopper network, which is a decentralized network, on the fundamental lower layer between the client and the server, or the web server you want to access, so the internet web server. In order to do that, we have to have some client on the laptop, let's say, on your user devices, which understands how that works, so it can interface with the Hopper network. We have to have some entry node, that's a Hopper node, which is talking to the Hopper network and translates normal internet traffic into Hopper traffic. And on the other side, there's something called the exit node, which then takes Hopper traffic and translates it back into internet traffic and talks to web servers, websites, and so on. So as you can already see, we've removed this single point of trust and added a decentralized network underneath, which will help you get this trustlessness, this decentralization, censorship resistance. Just to give you a little bit of insight on what the Hopper network does, and this is very high level, really. If you're interested in more details, I'm going to be around and my team as well, so we can give you more details in the next room afterwards. The Hopper network is a mixnet. The idea of a mixnet is that whatever data comes in is being chopped up in small packets, which all look the same size-wise. It's all encrypted, and then it's sent through many different paths through the network. We call that hops. And eventually we'll come to the destination where it's going to be reassembled again. And then you get the final data together. In between, none of these hops which the packets pass through can actually identify what the content is, obviously. That would be detrimental. But also, any adversary who has access to these hops in between can only look at the hop, but cannot really follow the packet flow. The reason why this is important is if you can understand packet flow coming in and out of a system, a server, you can actually understand what is going on, who's communicating with whom. So what we want to do is we want to hide that knowledge. And a single hop is doing what we call mixing. So packets come in, it adds latency, it changes the sequence of packets, and then sends them out again. So when you look at that from a technical perspective, you see packets coming in, and you can never make that relation from a packet coming in to a packet going out. And this is really important to counter any adversarial observation. The second fundamental improvement of what the Hopper network does is it makes it sustainable to run a Hopper node. Every packet which is going through the network is actually incentivized. So you as a Hopper node runner are incentivized to relay packets through the system because you're constantly getting paid for it, per packet. And this is important because otherwise, why would you actually run a node? It has to be sustainable in the long run. It's a decentralized network after all. Okay, so coming to our workshop here, let's assume, just to kind of build the scene a little bit, we're at a conference, your favorite conference like DappCon. You want to have anonymous internet access, so the DappCon organizers provide you access to Hopper nodes and want you to run Node VPN connections and browse the internet over the possibly insecure Wi-Fi here. So this was what we are going to do. We're going to set up the VPN client for you. Now, in step number 1, and this is maybe a little bit small for you to see, but this is our original architecture, right? And step number 1, you need access to a Hopper node, which you can get from my colleagues. Step number 2, we will install the Gnosis VPN client on the client machines. and configure them, the client. Then step number 4 is we're going to establish a VPN connection. So this is already then establishing a fully encrypted VPN tunnel. And step number 5, we're going to browse the web, the ultimate goal. Okay, so we are going to go into the terminal, so you can either copy that or type it out, but you can also follow that link. I put all of the long terminal commands on a web page, so you can just copy paste it and hopefully not have any typing errors. Oh, I need access to Hoppernode as well. Obviously, no cheating here. Okay. All right, so step number 1, I'm going out of the slides here, is we have to download the install script. Since it's still terminal-based, we've prepared a bash script to make it really easy for you to download the binaries which you need for your particular system, if it's Mac OS or Linux, and build the initial configuration. So I'm going to take that link. Is that actually readable? Is that better? Okay. So I'm just copy pasting the same command like you would do. I'm downloading the install script. Check what I've downloaded. You should obviously later, you can inspect that. This is a very exhaustive install script. It tries to give you as much information as possible, what's going on, what are the next steps which you should follow. So it's really like a tutorial in itself. And then I'm going to install a particular version. This is just for making sure while the product is being improved, I'm sticking to a version which will work for us. So I tested that version in particular, so we have a working experience. Okay, so the installer gives us a lot of information on what the requirement is, basically what I just mentioned already, so I'm going to skip over a lot of this. And we can just go through the steps by clicking enter. Now I'm being asked, where do I want to install the binaries in the configuration file? This can be anywhere on your machine, obviously. So you can enter any directory. I'm just going to use the default here. So just clicking enter. Then I'm being asked for the Hopper admin interface URL. This is just a convenience feature. So if I already have access to Hoppernode through what we call the admin interface, I can copy paste that URL in here, and the installer will chop it apart and get the right information from it. What you got from us here is the individual pieces of information, so I'm skipping over this part. And now it's actually asking me for the information from our vouchers here. So enter Hopper D API endpoint. I'm going to copy what I have printed out here. So it's IP and port. Double checking, okay. Then the token. Talk to the API. Okay. And then I have to enter so-called session port. So a Hopper D node can support many sessions at a time. And as a user, I have to just specify one particular port. Since some of these nodes might be used by different people, since these are demo nodes, everybody has a specific port assigned. Normally, if you have your own node, the default port is 1422, and you would never have to change it, really. You can use the default. So I'm using a different one for the demo here. And then it's going to check whether API access is working. It will download the binaries themselves. And this is macOS specific. I have to de-quarantine the binaries because on macOS, if you just download binaries, they are not usable. So the install script tries to do that for me. So I'm just having to enter my password here and complete. Okay, so this all has worked. So this is good already. This means I have access to a Hopper node. It was reading the API. It understood in which network the Hopper node lives, so the production network. And it configured, we can look into that, it pre-configured kind of a default configuration for me. So what this configuration shows, and you don't have to really mess with that here, is all of the information which I put in on top. And on the bottom, a set of servers or destinations which I can connect to. And very specifically, this is configured to use one hub. So we are already going through multiple nodes in the network, in the peer-to-peer network. So our packets not only travel from my laptop to the destination node, the exit node, but rather over two nodes in between. And as you can see, this is not IP data or anything. This is peer IDs, so basically a synonym in the Hopper network to address servers or peers. Okay, now I could just follow the commands which the install script has given me here, as you can see here. This would work just fine. I have a little bit shorter variant in our slide deck. So I'm just going to copy paste from the slide deck. Or from here, that's easier. So you could do the same thing. So first, what I have to do is I have to start the service itself. The service running on your machine has to have elevated privileges. That's why I'm using sudo, because it needs to create a network interface and a tunnel. So you do this once normally, and then it's being run until you stop it. And you can create new VPN connections throughout the day. So this is a one-off operation normally. So I execute nose VPN as a service binary and point it to the right configuration. The service will basically do nothing on startup. It will just enter the listening mode and then wait for instructions whether you want to connect to a particular server. So you have to go into a different terminal and use the second binary which we downloaded, and that's the control binary, right? And this is used to send control commands to the service. So I'm going to use that first to check the status. And since I haven't done anything yet, the status is disconnected, the VPN tunnel is down, but it shows me the different servers which I can use as exit nodes. So here I'm just going to use the one in Germany. I'm copying the peer ID, and then use nose VPN control, connect, and the peer ID. Hit enter. And then we already see on the left-hand side the service. Jump me up again here. Is then going to try to establish a connection to the server I'm trying to connect to. Let me check the logs here. Seemingly some error. Typical demo. So let me try a different server. Maybe I have a problem accessing that particular server. Let's try Spain. Okay. So this has worked. So now, I'm not going to stand up for this. I have a VPN connection established. So if I check the status again, it tells me I'm connected to a particular peer and my VPN connection is up and running. Great. Now what I have to do is, since this is still a proof of concept, it's not being used for all of the connection and the network access you do on your machine, because that might be detrimental if the quality is not great yet. What we do instead is we offer an HTTP proxy on the other end, which you can configure in your web browser or in your system settings. So for this demo, I'm going to configure that HTTP proxy in Firefox. So going to Firefox settings, and then into the network settings. And here, normally you would have something like use system proxy settings or no proxy. If you want to use the VPN connection, you then have to configure the HTTP proxy, which is on IP 10.128.0.1 and port 3128. You have to make sure that it's used for HTTPS as well. Now this HTTP proxy is actually on the other side of the VPN tunnel, right? So by doing that, you're actually already going through the tunnel itself. So I'm going to hit OK. And then checking whether the VPN connection works. And it's able to load whatismyip.com to test. What I wanted to show here is, and maybe I show it in my other web browser, which is not using the VPN connection. Just reloading that. If I go through the Wi-Fi here, I am being terminated here in Berlin. It's showing me even radial systems, which is our location here. If I go through the VPN connection, which we just established, I'm being terminated in Spain, where that server which I connected to is located. So I can verify that the communication is indeed going out through Spain to the internet, and I can then can continue browsing through that connection and visit websites as normal, right? So this is kind of a functioning setup now of my local Gnosis VPN setup. Okay, I'm going to just assume it worked for everybody here, and if it didn't, feel free, just so we don't run out of time, feel free to catch me or my team outside, and we can troubleshoot your setup if it didn't work. Now, I already mentioned it, this is Linux and macOS specific right now. If you are on Windows, it's a little bit more complicated. We don't have a native version yet for Windows, but we have something which you can make work through the Windows Linux subsystem. So just follow this website if you want to try it out, and I certainly would be happy to hear from Windows users who tried this in order to understand what the user requirements are. We can jump over this since it's essentially what we just went through. Okay. I mentioned this is using Hopper underneath. You already saw it's also using WireGuard to establish the actual VPN tunnel. And then it's using the configuration in the web browser. So there's a lot of components involved to make a successful private connection work. And this means that there's a lot of packet tunneling going on. If you look at it from the high-level perspective, a working internet connection to a web browser is normally just an HTTP connection, which is TCP-based, and it's end-to-end encrypted, right? So you can be sure whatever that connection is sending over as a response, or if you send something as a request, nobody can actually look at it. So it's end-to-end encrypted between your web browser and the web server. And obviously this has to stay that way over a VPN connection. Nobody in between should be able to decipher what's going on. So what happens is with that running VPN connection, the web browser will actually talk TCP to the WireGuard client. The WireGuard client locally will talk to the Hopper entry node. That was the node which you got the API information for. Will talk UDP because that's what WireGuard uses to tunnel data. So it's already wrapping, splitting up TCP packets into UDP packets, doing additional encryption. The Hopper node will send Hopper packets through a decentralized network. So that's again taking UDP packets, turning them into Hopper packets, doing even more encryption. On the other hand, on the other side, on the exit, we get Hopper packets. We have to turn them back into UDP packets. Then WireGuard has to turn UDP packets back into TCP packets, which ultimately are being sent from the proxy to the web server. So it's a three-level wrapping and unwrapping of packets from TCP to UDP to whatever the Hopper nodes speak with each other. This can be very complicated. This obviously uses a lot of computation and therefore increases latency, which we use in the end also to improve the privacy of that connection. Okay, so given that we can already establish a working VPN connection over all of this locally, like we saw earlier in the terminal, what are the next steps? I mentioned that this is the POC, so we have working binaries which can create end-to-end encrypted connections. We can browse the web. You could use it on in your daily workflow to browse the web. The next step is to build something which is normally called an MVP, which is not only more private, but also more usable, because ultimately a VPN connection which you can only establish by dropping into the shell is not really usable by anybody outside of this room. So we want to make it, we want to add some more privacy primitives, very important stuff to the Hopper protocol, but also we want to remove the dependence on a separate Hopper node. Obviously, if all of you would have to run a Hopper node, set that up, configure it, keep it running, that would be quite the requirement in the long run. Now, I expect all of you, since you're in here, to go out and install a Hopper node and set it up tonight. But I don't expect that for the next 10,000 users. So what we want to do is we want to take the Hopper node, make it possible to turn it into the library and add it into the client itself. So that ultimately you start up the VPN client locally, it starts up in, let's say, 10 seconds, and all of a sudden you have a working Hopper node running which can connect to the decentralized network. The end user doesn't need to know about Hopper. This is really a technical fundamental insight which nobody should care about. And once we have that MVP, we have to take care of making it as usable as a normal VPN client. So we're talking about all of the platforms, mobile, desktop, Windows. We have to have incentives so that if you want to run an exit node, if you want to become part of that ecosystem, it should actually be good for you. You don't do it for ideological reasons. That is great, but you also should get incentives out of it. And then we need better throughput. While you can already browse the web, you might want to do other stuff over the VPN. If we want to tunnel all of your traffic from your laptop, which you're doing on a day-to-day basis, through the VPN connection, we have to have much higher throughput than just what you need to browse a website. So there's a lot of stuff ahead of us. We have a timeline which is outlined in the GIP, which is going over the next 1.5 years. So if you want to follow us along, it would be greatly appreciated. We rely heavily on feedback. So since we don't do, obviously, any tracking in our clients, being very privacy concerned, we rely on feedback which is actively given to us, so very much appreciated if you want to share kind of your user stories, what's important to you as a VPN user, so we can take that into account. And ultimately, if you want to see when there's new product updates, just follow us on hostvpn.com, where we push every time we have new product updates, some news. All right, thanks. Now opening up to questions. Any questions? I think there's a microphone in the back, maybe. Might be easier.
I just came in the last minute, so sorry. Does
Okay.
it work on IPv6? Because my DS Lite connection at home, I don't have a public IPv4.
It should work on IPv6, yeah.
Okay, cool.
Yeah. Great. Any more questions? Okay, one up front. Can we get the mic? That's fine. Yeah, it's fine.
At what step runs the mixing? Because it's a mixnet,
Yes.
and there is a hopper node, and they
Yeah.
communicate that. Could you
That's
explain, please?
yeah, that's a great question. So the mixing obviously runs within the Hopper network at every step. And the first step is your entry node. So if we go back to that overview, hold on, here. So the first mixing is actually done when the packets are created and are going out of your entry node. Even there, let's say you are making an HTTP request which ends up being 10 Hopper packets, so packet 1 through 9, 1 through 10. Even then, we already changed the order, the sequence, and add latency, and send it out through different paths through the network. And this same process, adding latency, changing the sequence, happens on every hop in between. So in our example, it was one hop, so that means there was one node in between which did the relaying, which also did some mixing. And then the packets end up at the exit node, which only puts it back together, right? So there's no mixing involved on the exit node. So it's, if you want to look at it from this example, it was 3 nodes involved, and the first 2 do some mixing. Say again?
They send packages to the second node, or there are other some steps of the network?
Okay, the question is, do the packets go to the second node or somewhere else, right?
I just don't understand. I just didn't understand if when the packages are mixed and sent to different nodes, or how it.
Okay. So what I was referring to is the mixing of packets for which you choose a particular path, right? But what happens, obviously, let me go to this one, no, this one. The node, the relay node in between is not only serving me, it's serving maybe 50 other entry nodes and on the way back some other exit nodes. So there's lots of packets coming in from different sources and destinations. And this is all going into that, what we call the mixer, the process which adds latency, which changes sequences. So it's basically mixed up, it's being put into a bowl altogether, and then stuff comes out again. Some packets go a different route because they have different destinations, so that ultimately for somebody looking at it with a high-level network view, it looks like there's random packets coming in from different transport connections, and there's random packets going out. No packet looks the same because of encryption and decryption going on. No packet, every packet has the same size, so you cannot really make that one-to-one link between packets and understand, based on the metadata, who's doing what through that server.
A mixer is a part of a node, or
Yeah.
is it separate?
It's in the node. It's like an integral part of the transport pipeline in the node. Yeah. Any more questions?
How many exit nodes do you have in the Hopper net, or is every Hopper node also an exit node?
Also a very good question. So for the Node VPN use case, exit node has to be specific to the VPN use case because it has to understand, it needs to terminate a VPN tunnel, right? Not just talk Hopper. So while potentially you could run that sidecar exit server on every Hopper node, that is not the case. Right now, only Gnosis runs exit servers. But every Hopper node in the network could be used as a relay. The idea behind this approach is ultimately to have an ecosystem. So while we are in the POC stage, Gnosis is running the servers, the exit servers, because it's, for one, we can move very fast by deploying new versions. On the other side, we can provide good quality of service in this product development stage. Ultimately, though, we said we want this to be trustless and permissionless. So what we want is to enable everybody to run exit servers, register through some permissionless process, that they are available, given a certain usage pattern they allow. So let's say I want to run an exit node on my residential IP at home, and I only want to allow access to websites in Germany for some reason. Then I can configure that in my exit server and announce that through that permissionless process to the rest of the ecosystem, and then users could use my exit node if they are browsing the web in Germany only, German websites. And if they want to browse websites which are somewhere else or IPs which are located somewhere else, they just have to use some different exit server. Any more questions? Here's one. Last question.
I would like to know more about eventually the tokenomics. If I imagine, I'm thinking quickly, I imagine you want VPN users to maybe use, is it called Hopper, I think, the token? And validators or exit nodes, sorry, would get Hopper if they run a node? Like, are there other parts?
Yeah, that's a great question. So incentives, right? And I mentioned that incentivization for the Hopper network itself is important, but then also on the VPN ecosystem level. The Hopper network itself uses Hopper tokens to incentivize relaying. So every packet could be redeemed for Hopper tokens. So when you want to send out packets, you have to pay basically for the packet to be relayed through the network. Now this is on a different layer though than the VPE service work, which is done by the exit servers, right? I cannot give you a full answer yet, so this is kind of the kind of R&D we still have to do. So happy to talk about that afterwards separately. But we have to find a way to incentivize exit servers to do their job, whether this involves Hopper tokens or circles or whatever, I don't know yet. But there needs to be something. Yeah. Any more questions? Okay, great. Thanks very much for your attention. And if you have any more questions regarding Hopper, like the incentivization, I'm happy to chat about it separately outside also. Thanks.
All right, let's go. Welcome to the Vibe Coding Mini Apps workshop. We're going to start with a quick overview of what's actually going to happen because some people had questions with this long title. My goal is to basically take you from zero to have a live mini app. I'm going to give some background on why mini apps are cool, what I'm doing, and how to set it up. But then the main part is actually vibe coding. We're going to implement some features. I have some specific prompts that I'm often reusing. And of course, troubleshooting, vibe debugging is always there. And in the end, wrap up. If anyone was actually following along, you can share what you've done. You can share, you can ask questions, and we can obviously help you deploy it and go live. So while listen to me, just a quick challenge on why I'm here in the front and not in the back. Vibe coding. So I've built the #1 open source Farcaster client. That's why I'm building on Farcaster. And currently I'm building Vibes Engineering, which is kind of a factory to generate mini apps. So I have experience from when mini apps on Farcaster were introduced. And I'm celebrating 20 years of writing code this month. So I'm old and I've been writing code manually for a long time. And now switching to actually using LLMs or vibe prompting a lot more. And I'm active on Farcaster and in crypto for a while. So why mini apps? That's basically me trying to explain why mini apps are nice and you should build them. It's super easy to get your users to actually do something on chain. So I think everyone is struggling with the discussion on how from protocol improvements to actually get users, get people to do something with blockchain that is useful to them. So with mini apps in 3 clicks or sometimes less, you can actually help them do something and get the value on chain. Few great examples that do this. I recently went to the US and just bought an eSIM 5 minutes before my plane took off. So just in a mini app, I opened it from the feed. I had USDC in my wallet. And Kartik built it so that it's just an eSIM, so I can use it from my phone straight away. No emails, no contracts, no user data is leaking. I just have an eSIM that I can use. The second example is something that I vibe coded, a fundraiser to get going, so people could offload their meme coins that they had on any chain, any tiny amount. They could just donate it to me cross-chain straight from the feed. It was successful, and I could just pay for my trip to New York to see the conference. And the other 2 examples are more social and more game-like, less on-chain, but also interesting. The third one on this slide, where you're at, is sharing your social graph on a map, so you can check in certain locations, and only your followers can see where you're checking in. And the last one is just a game. There's a bunch of different ones. This is a take on Wordle, which is interesting, but here again, you compete against your friends, and you can mint your success on chain. So from utility to actions, you can do a ton of different things with mini apps. This is kind of a ton of memes on one slide, but the mic works? Sorry, there's some hiccup, right? Okay. So I'm also confused right now with the mic. So going from confusion to actually shipping your first mini app, that's the goal in a few tiny steps. And how you can do it. The main one, I see some people with laptops here. So if you have a laptop with you in the room, the easiest and what I'm going to show you is actually from a laptop. The other one, if you just brought your phone or you're at home and want to watch the live stream, there is a way to do it, but I'm really going to focus on the first part. If you want to vibe code along, scan this QR code or go to vibes.engineering/go. You're going to see some documentation, a bunch of links, a ton of useful content that you can use in this session, and you can bookmark it for later. It's going to help you get set up much faster. tapping on the phone, I don't want to promote it too much, but that's the app I'm building. It's called Vibes Engineering. It does the same thing from your phone. But I'm not going to talk about it further. The main thing is just free access, what everyone can do at home, vibe coding from your laptop and going from zero to a live mini app. So that was most of the slides. Now we're switching to actually checking setup and how to get started in a few minutes to see, maybe this works better, to see the very initial mini app that you can use. Can you see this in the room? I think that's important, if you can read the text. Is that possible? Cool, thank you. So what's needed to have a mini app? You need to have a starter project that is linked in the repo, and then usually you just do npm install and then dev to get going. One important piece to actually have a look at the mini app, not in your browser, but as other people will see it, is you need to look at it in the preview tool. And for the preview tool, you need a small tunnel from your local developer setup to the Farcaster preview tool. And for this, I'm using Cloudflare. There's a bunch of other providers. I'll be using this one. And of course, the third terminal or the third piece for vibe coding, you need somewhere to submit the prompts. I'm using Cloud Code for this, and we can see a bit more of that later. And now to check out a mini app in a preview tool, this is how people will actually see it. As you can see, I just copy-pasted the address in here, and then you can open it, and this is my generic template starter that you can also use as a starting point to vibe code from here. Important, different than other websites and other approaches to this is by just opening the website, you as the app developer immediately have data on who's visiting the website. So you see the Farcaster user ID, you see the username, you see their profile picture, a bunch of things to immediately customize how the app looks like and how make it valuable. And you see some other data that we can skip for now, but you can basically also send haptics and register the mini app. You can have a bunch of different actions, and the key things that I want to show is how easy it is to send on-chain transactions or do things on-chain versus connecting with MetaMask, Wallet Connect, going through all of this pain. The easiest thing, or the easiest example, is just signing something, which is one click. You can send ETH. If I had enough money in this wallet, in this test wallet, I could send ETH, which is just one click, and you can also sign type data, where you can check out the data here, and also just confirm it and make a signature. This is not just for base or specific change. You can also just change the wallet connection without the user having to do anything. So all of this is already much simpler than other environments. Then another example that is baked into the template starter, just to show you an actual on-chain transaction of minting an NFT. It took a while to load. So this is a dynamic NFT component where you can just submit your contract address, and it will render it nicely, and you can just forward people to mint it. It will fetch the price, and it will switch the chain automatically, what you've seen in the background, and then hopefully I have enough gas that this works. And this will just be the first mint of this NFT that I've set up. If you also want to have kind of a pour-up, you can also mint it. And that's just a quick run-through of everything that is in the starter template and how easy it is to actually do on-chain transactions through mini apps. That was the first part of just showing where you can start from and what you can do. Now the second part, the longer part of this session, will be the demo of actually vibe coding, building new things. And I just had this idea yesterday, So because everything here at DappCon is very circles focused, I thought about building a mini app for circles with the very simple use case where you see a list of your Farcaster friends, meaning the people that you follow, and check if they're on circles, and if possible, trust them on circles as well. So we have an environment that I just showed where we know who the user is that logged in, and we know the Nena API, which fetches Farcaster data. We know circles, or at least that's in my preparation. What we're going to do live is how it should actually look like, and if we can do it in the time that we have here. But that's going to be the live component of we're prompting Claude code, and we want to see the app that comes out of it. So I'm going to switch to my editor, and hopefully we'll get some interesting things happening here. I'm going to keep the editor on this side and just quickly rearrange so that you can see the mini app that we are generating is on this side. Doesn't look as nice, but I think it's fine. 1 second. Here we go. Okay, nice. Now to the interesting part of typing things that I haven't seen as well before. So this is going to be fun. The first point is we just want to show a list of friends on Farcaster, which I have this existing Farcaster account, which is called Vibes Engineering, and I follow a bunch of people, and I just want to see a list, or anyone who opens this mini app should see a list of their friends. So it's immediately personalized. It's immediately something that people don't necessarily see every day or have access in the context of circles. So I'm just going to type, use the Nena API to fetch my Farcaster friends for the user. For the user who visits the mini app. Let's see what it does. This session might have some pauses and some waiting for LLMs. So I'm just trying to explain it, if you can't see it that well in the back, on what's happening and what Claude Code is actually doing. And I have a bunch of stuff prepared as fillers, so it's not going to be too boring. So here, the first step that I'm always trying to prompt before it runs into mistakes is making a to-do list. So in the background, I created a Claude MD file, which is the default way of Claude Code to have kind of a repository or knowledge of the repository. Meanwhile, it's just asking to install stuff. We can say yes. And this Claude Code file already, this Claude MD file now already knows my preferences. So I already told it, hey, I have a development server running. Please don't use pm build, or don't create new production builds while I'm running this development server, because it would break the demo that we're doing right now. And I also gave it the task to always say, give me a list of give me a to-do list of the items that it should do, and explain them, and give me a nice overview of what you're going to do, and usually as well tell me a few different options. And I did that. I've prepared some examples here with different prompts that I'm regularly using. So one of them is, give me suggested solutions. I'm usually working on startup prototypes, so that might not be relevant for everyone, but I'm using a startup prototype, focus on 90-10 impact to effort. So give me simple solutions, don't over-engineer it. Many people have problems with vibe coding, because if you just let the LLM run its way, then it's confusing things. It runs into insane corners. It tries to implement enterprise features that you don't need. So I gave it some constraints here, and I always tell it to follow clean code conventions. I have another prompt that I'm often using is I'm telling Claude Code to ask me questions for anything that it might not know or that it needs to know before it can proceed confidently. Explicitly saying, don't write any code, just respond back. Let's just have a conversation. In Claude Code recently, they added a planning mode because I think many people ran into the same problem. But I still often use this explicitly to tell it, don't go crazy. And the longest one that we don't need to use yet, but I'm just sharing it while the LLM is still thinking, which is a code review. I don't have many humans on my team, so I'm using LLMs to also do code reviews. And I'm just asking, is there breaking bugs, any crucial breaking points? So don't give me small typos, don't give me minor things that I don't want to see right now. Just focus on the huge items that I need to fix before deploying this to production. I'm telling it to find root causes, which means I don't want a superficial solution that just patches one tiny case, but doesn't go deep enough and actually fixes what is wrong. And I do a similar aspect of the prompt where I just tell it, suggest a few solutions. Don't just nail down or focus too fast on one thing. Just give me a few options so that I can select which one I like the most. This was a huge unlock for me, to be honest. That's why I'm promoting it. Maybe it's common knowledge by now, but just saying, give me a few options. Usually I have a specific opinion on which one I like best, and if I just tell the LLM in vibe coding to run as fast as possible with anything that it likes, it usually goes off in a wrong way. So having these points where you force it to go broader and give you a few options, and then you pick one or you have a deeper conversation about one, usually helps a lot. And again, some guardrails against, especially in Anthropic models or in Claude Code, don't touch irrelevant parts of the code. Focus on where you actually need to go. Don't scan all files. Don't go super broad. Don't go overboard with things that are irrelevant to what we're doing right now. Maybe other things are breaking in the project, but I want to focus on a specific problem. So I'm also telling it this aspect, and I'm telling it again to just respond back and don't fix things immediately, to have this conversation about a few different options. I think now is a good time to just check in on what the LLM is actually vibe coding. We can refresh here and see if it already implemented some changes. Doesn't look like it. Let's analyze where it went while I was rambling for a while. Okay, so it's trying to connect to its own API endpoint that it created, and apparently there's just some type error that I'm seeing here. And now it's asking if it can run a checker. Let's see which API endpoint it actually created. We can go in here and see it successfully vibe coded fully without us looking into the Nena API. It created a Nena client. It knows we need to work with a certain FID, which is the unique identifier on Farcaster. And then we're getting the data back on who is the user following and who are their followers, and returning the list of FIDs. So this all seems good. Now we're waiting. while we're waiting, I can continue explaining some aspects of the mini apps. Tim is here from Kiwi News. That's one feature he uses a lot, and he saw a huge bump in traction from using the feature of adding mini apps to the Farcaster client. For this, I need to change the example that we're looking at. Where you can send notifications directly to the people using your mini app with this dialog that you can just prompt for people to see, which I'm using this weird name, DappCon mini app template, which isn't really useful, but it could be a single word circles. So here you can just read add mini apps circles, and then you can add it to Farcaster. And then you have the permission to send notifications to people, which on Android and on iOS, it looks like a native notification. So if we open this window here and just look at the mini apps that are all pinned, this is my developer account, so it's a bunch of developer apps. All of these apps can now send me notifications that will just appear in my feed as regular notifications and on my phone as regular iOS native or operating system native app notifications. And as an example, I have a few here where here we're saying, thanks for adding this mini app. And up here you can see a bunch of notifications got grouped. Now you can see it for this mini app that I'm building. Repeatedly sending notifications, they get grouped, and you can still reach people with updates. So for me, I'm using long-running jobs in the background, so it makes sense. For Kiwi News, as an example, if there's breaking news or if there's trending topics, you can easily also notify your users to come back to the mini app, to re-engage, to be aware of the trending news. So that's a very useful feature that is as far as I'm aware, pretty unique to mini apps. And now we see the Cloud code in the background finished, so we can check it out again. Let's open it. And here we can see we need to go to the Friends page. It navigated us to the wrong page. Great success. Let's do /page. I want to see the Friends page as the default when I open the mini app. And what else do I want to see? And I want to focus on only seeing people that the user follows. So we only want to see the friends. I think it went in some slightly wrong direction where it also checked the followers, where it's pretty irrelevant if people follow me right now and they're also on circles. I just want to see who I'm interested in. Focused on followed by the user and not on their followers. Now again, we're getting the to-do list, which is just, I talked about the main page, it understood the API needs to change, and updating the friends component should also be there. And now for the first time, we actually see something interesting that immediately fails, but it updated the changes immediately to change the main page. And we're getting some error because it's also updating the API endpoints. Let's wait until it's done. failed to fetch friends. It's kind of sad. Let's see. Because we don't know where the error is, we might need to look into this thing. Failed to fetch friends. That's another pattern that I'm often doing when developing mini apps, because there's the server-side component that has the route and makes the API calls, which I don't see in the browser really. And then there's the browser side, which is running the mini app, which is throwing errors for some reason. But when we click here, we only see the front-end error, which doesn't give us any information. So I prompt the mini app to say, log the server-side error, so we can debug this better. And understand why the request fails. Sending this. That's an interesting newer feature that I haven't seen in Cloud Code. I think maybe last month was the first time it showed up, where it's actually writing curl commands or tiny scripts to check on your local setup, which is a very interesting feature. I don't have to go around and debug, is my local server running? Is there a connection error? Is this API actually returning what it says it's returning? Or am I doing everything correct and Cloudflare is down, as it was last week as an example? I was vibe coding last week and I thought I had a ton of bugs in my system, but it was just layers of database and Cloudflare and other servers being down. So this thing helps automatically debugging as well. Okay, now we added debug logs as well. Let's give it another try. So we don't know why this happens. Okay, this seems like a crazy error. Maybe it's a good example of what I'm usually doing. Not usually. I'm still doing some stuff manually every now and then. But for this example, we can just copy paste the whole thing and use our prompt that we had here in saying find the root cause and not just focus on. I can copy paste this. So now we will see it will provide us with a few different solutions. It shouldn't touch the code. It should really only touch the code once it's really obvious and it's maybe missing a package or has one simple clear solution, but generally now it's doing a code review and checking what's going wrong. And here it gives us a few action items. Where we don't know. Should we go deeper into the live debugging? We can check the Nana API. Because I know the end file is set up correctly. Valid FID is 3. Log 400 errors more precisely, so we know what's up. check. Maybe this is the problem, that we're not setting the environment variable. So one thing to actually communicate between the front end and the backend might be that we need to set a specific environment variable so it fetches our data correctly. Still no success. So we're getting a Nena API error. This is very bad for the demo because it never happened to me before. And I actually don't know the solution. Oh, here it is. Limit must be between 1. Yeah, it was 200. I expected this account to have many friends, but Nena tells us we shouldn't fetch 200 friends. It should be less. Okay, I'm relieved. Hopefully we'll find a list of our friends now. And here we go. We have some vibe coding success. I was nervous for only a bit. Perfect. Because now the actually interesting part, or more interesting part, is in how we connect this list of friends to Circles accounts, where I found some API that returns this data for us. In every Farcaster user has a bunch of connected Ethereum addresses. So you can, it's called verified addresses, and each user account or FID, they live on-chain on Optimism, but you can verify on Solana, on EVM, and soon a bunch of other places that you own certain accounts, which is really relevant for us. For now, I know Franco here, he has a Circles account, but maybe not all of his Farcaster addresses are actually connected to Circles, only maybe his main ENS address or a different one, and we want to find this connection between Farcaster account and Circles account. And we have some API prepared for this, and this part actually worked in the test yesterday, so I'm more confident we can get this done quickly. Where we can now copy. Maybe we make our lives easier and just say finish the workshop plan related to the Circles integration, so we can look up the connection between the Farcaster friends that we're showing, and if these friends are on Circles too. And if they are, I want to open their profile right in the Metri app so I can trust them, which is, I know these people for a long time from their online activity. Some of them I have met in real life, but not all of them. But I would still trust them on Circles. So this is what we can show here. We want to open the Metri app. Contract address, maybe user address. And we have a typo. So now this just simply making one API call and showing all of these people works. It might take a while for the rest to finish, to do the full Circles integration. If anyone has questions in the room or online, we can go through them while this is running. I can keep rambling about features in mini apps because I'm excited about them. But if there's concrete problems, specific integrations, or questions you have on mini apps, we can also go over them now. Any questions? No questions. Tim?
Can I also deploy contracts with this? Smart contracts or?
Can you deploy contracts? Yeah, you can make any on-chain interactions, anything that you want to do. So there's a list of, there's kind of a permissioned list of blockchains that are supported right now by Farcaster. They are being challenged by Coinbase Wallet, which will also be a Farcaster client and which supports many more chains. So the assumption is basically all chains will be supported in the next few weeks or months, and then you can deploy contracts on any chains as well. Some people already do it to deploy Gnosis saves, which has like specific deployments or is just one type of contract, but you can probably also just have a even Solidity editor and deployment button in a mini app. Yeah.
So if you run a mini app, how much do you spend on Neinar and Cloudflare? Unless it's like, let's say, mini apps that you deployed so far.
Yeah. So the question is how much we're spending on Neinar or other tools around mini apps in API providers. So for me, it's to be specific, I just have one paid plan on most of these providers on the lowest tier. So it's not crazy expensive. It's not immediately you're jumping to the enterprise tier. So I had some apps that I showed before, for example, the Vibe-coded fundraising tool, which had a ton of traffic, even though only 70 people donated, many more people opened it, and all of them generated traffic, including Alchemy requests on the funding, just Versal for hosting, and Neinar as well. So maybe to sum it up, it's $100 per month, but you can start with all of them also on the free plan. Neinar has a free plan on where you run the mini app. You can also do it. A bunch of APIs and requests are also served by Farcaster directly, so these are all free as well. To send notifications if you're not on the receiving side, what I showed, but on the publishing side of sending notifications, all of this is free as well. So, I mean, there's always these Versal screenshots of people going broke because one of the apps are trending. Luckily, Farcaster isn't that big yet, so I don't think the total market will ruin you. It can run into problems, but it's pretty doable to do one for free. Yeah. Yeah.
Thank you. So basically, the mini app is a URL, it's a web application, but that's open inside the context of Farcaster.
Mm-hmm.
Right? Is this understanding correct?
Yeah, so the question is, where are these mini apps actually running, or what is the context of where they're running, and is it a website, is it a mini app, what's actually happening? So the easy answer is, yeah, Farcaster is just the wrapper or the host of a website, and they added some fancy sprinkles on top to make it easy to have the wallet connected. So it's a social client, but it basically has a wallet baked in, and it's automatically connected. And through this, you're skipping the annoying wallet connect part, identifying with different services. So it's just a simple host where you run a website. So all of these things run on Versal for me. And that means you just get a URL that you can post on the internet, and other people can also use it. But if you open it on Farcaster, it has some special properties to run easier there, to have some additional features. But you're not blocking people from accessing it. It's not exclusive. It's not iOS versus Android. It's just a link in the end.
Thank you. And also, for the API, I saw the user data without signature, that this user data is authentic. So, yeah. Will this be later, this authentication, or what's your...
Yeah, very good question. So the question is, I showed, we vibe coded it away. But in the beginning, you saw the context of the user viewing the mini app. And the question is this verified? Is this authenticated? Can people fake it? And yes, people are faking it. The initial loading of the page, you can fake it and just act as a different user, which is helpful in debugging as well, where I get user reports that something isn't working, and I can log in as if I'm this user for simple tests. But there is verification, there is signatures that can happen in the background. There is a new, it's called quick authentication from Farcaster, which can just happen in the background. And through this, you can check, can you trust the user? Which mini apps are also called frames v2, which hints as there was a frames v1 where this was a huge problem. Many people were just spamming it and trying to get to some airdrop, which happens in crypto. And this quick authentication method and a bunch of other things help to actually authenticate the user, often without them having to do an action, which is also very nice. So to the user, it still looks the same, but in the background, you're doing a bunch of handshakes that I didn't get into today to keep it more vibe prompting focus, but that's definitely a huge problem, and there is some quick solutions. Yeah.
Is there a way to see which of your friends have Miniapp installed already? Or like have added it to their Farcaster or anything like that? Or have played it before maybe? Like if I'm making like a game as a Miniapp or something, I want to find like friends or people that have already installed it. Is there a way to do that?
Yeah, so the question was, if someone opens a mini app, can you see who else has already opened the mini app? Are your friends already kind of in the game, on this circle, in this location sharing mini app, whatever it might be? I'm not aware that there is a public API for this. So I don't think there is a public API from Farcaster or from any of these other providers that can just easily tell you if there's a Tinder-like mini app and you would leak the data, hey, all of these guys are also on this mini app, there are some consequences to this. So I'm not aware. For what I'm doing, if someone adds the mini app, as I showed, if they add the mini app or pin it to the client, you just get a webhook request to save in your database or wherever you want to save it in key value store. So through this, I basically already know who has added it, and I have this list, and I can just also message people automatically or try to reach out to them. Hey, 5 of your friends are on this mini app. Do you also want to check it out? Or if they open it, I can show not this long list as we're showing here of people that I follow, but I can show them specifically, hey, these 5 people also have this app installed, or they were recently active on this mini app. So because it's just a generic website, you can do these kind of things.
Does that webhook still work in dev mode as well? So like the webhook will go back to the Cloudflare page, which goes to your laptop dev, and that works?
Yeah, great question.
Okay.
Yeah, for sure. So I didn't get into this part as well. There is a domain association step, which you have to do. I can just show it quickly here to focus on this part. You have this title, but then below it, it says by Vibes Engineering. Vibes Engineering is just my dev test account here. To get to this step in a live feed sharing system, you actually need to associate this mini app that you're hosting with your Farcaster account. And only then can you add mini apps to a client, or you can send notifications. So it's permissionless. You can just do it. You don't need to ask Farcaster to help you with it. But you need to connect between any domain and a Farcaster account. And that's kind of a blocker. If you do this in your local dev setup and saying, hey, this Cloudflare domain is legit, I want to connect it to this mini app, then you can do it. And many people do it because the webhook interactions and notifications should be tested in staging and not straight in production.
How do I do that? Because I did also add that add to Farcaster button, and it says invalid domain manifest, which I guess is that error.
Exactly.
Yeah.
Yeah, I think we have some time. Perfect. Let's get into it. So currently, let me zoom out. There is a bunch of developer tools on that Farcaster provides. So you just go to Farcaster, and then it's /developers, and you have a preview tool, you have an embed tool, and a manifest tool. And what we're talking about here is the manifest tool or domain association. And here you can just enter. Let's just use Vibes Engineering. And here we can already see everything that I registered, and it says when it was last synced. It says it's not connected to this current account, but with a different one. I can see the preview of how it looks like if it's kind of a minimized embed in the feed, or if it's a large one, and then you can see the full mini app configuration. There's a bunch of icons, images, text, splash, URL, and color, and even kind of App Store-like categories and tags that you can add. All of this just lives in a JSON file. This was the nice view to look at it on Farcaster. Just to give you the full view, it's always at .well-known/Farcaster JSON. So for every domain that has a mini app, you need to have this file. And it looks like this. So what I showed you before in the nice Farcaster interface, the raw data is just this. And here you can see the structured data is in the frame. And above that, you need to do the account association, which is connect this domain where this file lives to a Farcaster account. Now, the sad news is you need to do this on mobile. You need to generate the signature where your Farcaster custody wallet actually lives, and that's usually in the Farcaster wallet if you didn't export it. Now we can get into many more details. So this header, payload, and signature is easy to generate in the mobile app. You enter your domain and it will do it for you. And then you can just copy paste it to this .well-known/Farcaster JSON file. Side note on features that are coming from Farcaster is this is the most annoying part. That's why I didn't get into it from the start. It's kind of a requirement to go into production, but to have your first mini app live, it's more annoying than a requirement. Farcaster will offer a way for you to not do it and just point this file or redirect from this file to Farcaster. So they will host it for you, and you will be able to manage it from basically this manifest tool is not just right now it's read only, and in the future it can also write, and you can change the data or associate it with a different account. So this will blow up and will be a bigger feature than it is right now, but currently you still need to do it manually. Let's give one more try to the vibe coding. Did you implement the features? This is the point when I'm too lazy to read all of the output and I'm just asking for TLDR. Tell me what happened. Yes, please implement it. Okay, maybe we'll run out of time because we can't get enough tokens to quickly write the code for us now. So if we open this one, it still only shows our friends, which is it's nice to see the people we follow, but it's still without the circles integration, which might take a while. Okay, do we have any more questions? Okay. Let's give it 5 more minutes. If it will finish the feature, we can clap. Otherwise, we need to do a follow-up circles integration. Yeah, just to keep going, the workshop plan obviously was also vibe prompted. I ran into a bunch of problems with the Circles SDK. Let me find the SDK, which is here. So they have a nice description, and they have a bunch of things already explained. You can easily set it up with React. So this was super helpful, but for the specific case of I'm looking for specific Fahrkaste, or I'm looking for specific addresses that I know people have, and I want to check if they are on Circles too. This obviously wasn't there. It's kind of a niche use case. This is much more focused on setting people up with new Circles profiles, inviting them, minting the Circles, a bunch of different things. So I had to go through this a bunch of times, try 5 different approaches, where 4 didn't work, and then the last one actually I got to get the data. So the workshop plan already includes kind of all of this research, and I just told it, now that we solved the puzzle, just use the working solution and don't try to do different things. But maybe we have something else I can show in the meantime, which is the demo circles. While it now also tells us it finished the feature. Let's see if it actually works. That would be a great success. Let's go back to the main page, see what it does. Did we lose the internet connection? Maybe. Let's try this again with the new address. Yeah, I just restarted it. Let's restart it again. So I'm wondering here it says compiled. Okay, we can see something. And we're checking circles. This is new. So far there are 0 people on circles. We need to check all verified Ethereum. I can't type anymore. Ethereum addresses of the Fahrkaste users, not just the primary one. Okay, we can obviously continue vibe coding for a long time. I think that's a good place to stop. We have the basic integration between seeing the followers, refreshing it, checking if they are on circles. So far we need to, I think, check that we're using all addresses to look up and not just the main ones, which is a tiny hiccup. And yeah, if you follow me on Farcaster, I'll just share this later once it's done. And any more questions? No? I think then we can finish and leave it at that. That's it. Thanks for joining.
Well, hello everybody. Thank you for joining. I know it's rather late and it's an hour-long workshop, but I think we can even make it shorter because really the work that we're doing in ENSO is about making it faster to get whatever ideas you got to production, to get them on chain. So my name is Nenad. I'm Devrel at ENSO. This is the Twitter handle of our project, so you can also follow the updates on Twitter. And before we get started with the workshop, I will tell you a little bit about what we're actually building and why all of that matters. After we finish that part, we'll dive into the workshop, and it's something that will be very much hands-on. So there will be a couple of challenges that you will solve with ENSO, starting from something very light, going to something a bit more complex. So, let's say this is you, a developer, and you have an idea. You want to get something on chain. But to get there, if you want to integrate some protocols, you would have to do some of those integrations manually in the regular approach that we have. So that requires a bit of solidity, well, sometimes maybe even a lot of solidity. It requires audits, and of course it requires weeks or months of development and auditing work, and all along you just wanted that thing to get on chain. And we're trying to cut this path a little shorter, and we do shortcuts. So for devs, what we do, we are a cross-chain intent provider, meaning that you can call ENSO's APIs and say, my user has this token on this chain, they want it to end up on this chain in that vault or whatever, and this is all you really need to do in order to get a transaction that does a bunch of swaps, bridges it, and deposits it into the vault on your target chain. For users, this is blockchain shortcuts, because users don't need to know anything about, at that point, and they don't need to do anything around bridging, swapping, and depositing. For them, it's just one of my tokens will end up on the chain, will end up in a position, and that's the quickest way for them to get there. So this solves developer experience and cuts development costs, and also for users, it solves the user experience problem, like you don't need to use 5 different tools to get there. Now, we're going into the technical part of it, and we're making this possible via 4 APIs, 4 groups of APIs. One of them is about routing, and that's what you will experiment with today. The other groups of APIs are tokens or positions. So if you want to move liquidity, well, there are positions you're moving from and positions you're moving to. And when you have routing, so finding the path, and tokens, the things you're moving, you also need a way to express how do you intend to move those things. And this is where integrations come from. So this is all the dexes that are in there, all the vaults that are present, and this is how you specify exactly what you want to get. And there's a little bit of APIs that gives you information about wallets and TVL. So for us today, the most interesting part is the routing part, because that's where shortcuts come from. So it's practically translating this idea that you might have. You take a token, you deposit it, you borrow, you swap, and you deposit again. So this is what, for example? Looping. So this whole process of doing something with the token in a couple of steps, we can actually translate it into a single runnable transaction, and it's actually executing cross-chain. With the route API, so this is like the smart routing that optimizes stuff, we're doing swaps, but there can also be deposits and redeems. So these 3 operations mixed in a particular way will actually get your tokens from one position to another. And ENSO actually collects these and arranges them in such a way and chooses the dexes and liquidity positions that yield the best routing results. So it's practically the best output for the user. And essentially, this is like a little visualization. The only couple of things you need to specify are the input token on your origin chain, the output token on your destination chain, and these blue dots represent those little operations along the way. So it is constructed for you, and you don't need to think about who to pick, where to swap, when to deposit, what to withdraw, what's the primary, what's the underlying, and so on and so on. So in that sense, this is, well, solving a lot of developer experience issues that we're facing today. And this is routing. This is, as I said, it does something smart for you by optimizing the path, but you might want to get in the position where you want to control exactly what's happening along that path, and you want to add more stuff. Yeah, I'm going to come back to this slide. So there's also the bundle API, which is pretty much route API without that optimization. And here you can also have different actions besides redeem and swap and so on. There's also harvesting. You can add fees to those routes. You can borrow from protocols, repay debt. You can, of course, swap, because that's like the first operations many of us did. And when you're creating a bundle that consists of these operations, you can also include a route. So you have a pretty, let's say, static chain of operations, and then you can say, okay, and so, but for these tokens, do your optimization magic, get me the best path to a desired token. We good here? Any questions so far? Yes. So when you're bundling these actions, for example, swap will give you the amount of tokens it's swapped into, and then you can do a reference. I need to show you the code for that, and we'll get to that in a second. So you can actually reference, hey, I want the output of the third action in my list, and to use it as the input of my current action. Thank you. Yeah, this jiggles. And that's the bundle API. So again, lots of stuff happening here. And as I said, because all of this is cross-chain, there's a bridge action. So in the middle of that bundle, you can say, now bridge to another chain. And after the bridging is complete, follow up with these actions. So you can continue moving your liquidity on the other chain as well. And we need to talk about actions. So there's a bit more than 20-something, and this is a credits roll. I'm not going to read them. They're in the docs, so you will find them. But that was it when it comes to the overview. Now, for all of us who like to do stuff hands-on, you can scan this QR code. This is the intro to the workshop. So it will give you the necessary links and instructions how to, well, get started to do the next challenges. How many people would like to do the hands-on stuff? 2, okay. You don't have a laptop, okay. All right, so let me join the party then. All right, so this is the workshop intro. The challenges, the individual challenges will be released as we go along. And yeah, you see my screen? That's the wrong screen, I think. Let me just extend the display. I get a little help here? Actually, I'm good. Found it. All right, so you see what I see now. Good. So before we get into challenges, first couple of challenges you can actually do, perhaps even on your phone, because there's no code involved in those. It can be code-based as well, because in this workshop we'll use 3 different things. One of them is Happy Path. So this is a little widget that we built that actually allows you to move those things very, very easily. And this is something that you can embed into app UIs for the end users. So when you check out this intro page, you will see the Happy Path. Then there's the SDK option, or using the API directly, and a little helper tool that you can use. This little helper tool, let me just show it. So this actually shows you exactly which chains ENSO supports, and this is the current list, and all of this is really live. So this is coming from our APIs, and you can search for projects that are supported with their respective versions of their protocols and the chains they're supported on. So this is sort of useful if you want to dive into the supported tokens. For example, if you want to find what's the primary contract, what are the underlying tokens, and also query based on these values. So, for example, let me pull out all the tokens, all the positions that have USDC and as their underlying. So I would just say underlying tokens, paste this address, I remove Uniswap, and there we go, we got all of those. So it's a little query thing that can be helpful when you want to interact with particular specific protocols. But we'll come back, we'll actually go back into the workshop. And to get started, first you need to get the ENSO API key. So to do that, there's this dashboard button at the top. And when you click it, after logging in, you will get an API key, and I will need to get a new key after this workshop, apparently. And then you can use it somewhere. People who are following along, all good? Yep. Yeah, okay. So I'll copy the API key here, and I'll just start a terminal session and zoom this in. And maybe I just yeah, much better. Okay, so I'll just say, I'll just export this key in my bash environment. And after doing that, I'll copy the first command. Let me get all of these into one view. There we go. So I'll copy the first example, and this first example will actually give us all the things that we can do with Aave version 3. So I'll just copy this curl, and boom, you remember that credits roll that we saw with the list of actions, where here are the actions that are supported for Aave v3. So you have borrow, and then you have the exact inputs, which is pretty much like a type system description, how to interact with this protocol via ENSO. And at this point, I would like to just say one important thing. So borrow looks the same with Aave and with all other borrowing protocols, so same parameters, even though implementations are different. So you can think of this interface as a facade to many different borrowing protocols, standardizing the way you interact with them. Any questions so far? Yeah.
This thing on?
It's on.
Wow. So these endpoints that we're hitting, do they generally return signable data, or do they like expect you to provide a signer key, or like is there a standard format for the response you get from these things?
Yeah, okay, so this is just describing actions that you can take, right? So there's nothing to sign here. But I'm guessing that you're asking about something like this. So let's check out how the routes work. So you would call the API, this is via SDK, and what you get is a route with a transaction object. So in there's the recipient of the transaction, there's the call data, and all of that stuff, and you need to send that transaction, of course, from your wallet, so you need to sign it. So this is translating the intent, this token to that token, with possible bridging, into call data that encapsulates all of that.
And what about the case for like ETH sign typed data or something? Would it give you some signable message as opposed to just transaction data?
So it just gives you the call data, and that's pretty much it. All right, any more questions? Okay, so now that we've seen this, and I hope everybody got their API keys, you can choose either to work with curl, raw curl, or the SDK. I prefer the SDK, so let me set that up. Yeah, let me. Let me just set up a folder. Let me zoom in a bit. Oh, there we go. Oh yeah, PMPM doesn't have that. And now, let's open VS Code here. Okay, nice. Get this out of the way. So I'm just now installing the Enso Finance SDK. That's the second instruction you got in there. Since we're using PMPM, it should be faster. And there we go. We got that. All right, and I'll just create a new file here. Index.js. And we can get this going. So I'll just put up, an immediately called async function, because let's wrap everything. And from here, we can keep adding the code. Tell me if I can move on. Yeah, okay. So if that was the intro, here's challenge 1, you can scan it. And I'll switch to challenge 1 right over there. Just in case somebody needs a scan, here it is. Assuming everybody scanned it, let's warm up with a little bit of cross-chain swapping. So here you get to choose your own adventure. You can pick your favorite chain and your favorite token. And when we say pick a favorite chain, it has to be one of the chain Enso supports, of course. So we couldn't go with just about any chain. Let me make this a little smaller. So I'll copy this curl request, and there we go. We got a bunch of chains over here. again, the same chains that you would find in the navigator. And then you would pick your favorite token, and again, this is the API that allows you to get those tokens, or you can do it via SDK as well. So I'll run this one over here. And let's say I want to go on base, because that's the only chain ID I know by heart. Something happened here. All right. So this doesn't really look pretty. To make things easier, I'll come back here and I'll just say, okay, we'll go to chain ID base, and yeah, let's take USDC. So I'll copy this address. I will need it for later. And I'll just paste it over here back in my code editor as a string. So that's USDC. Now, you might have picked a different coin, that doesn't matter. And let's move this, let's swap it into Bera. So let's move the USDC that we have to Bera chain. So for that, let me just go over here and do another search. Bera chain, here we go. And yeah, I'll just skip the address because I'll copy it here. So there's the Bera token, and of course, it's the native token, so it's got the E address. And let me paste that over here. So now what we want to do is actually create a new instance of the ENSO client. So it's just new ENSO client. And we need to pass two things. Well, the base URL is not really necessary, but we need to pass the API key that we got previously from the dashboard. So I'll go back there and I'll just copy it from here. And yes, I know this is like a big no-no, but I'll paste it because this is a workshop and I'll reset it later. All right, now that we have that, what would we need to do? Like, this is a call for discussion. What would we need to do to achieve this regularly? What would be the steps? Come again? Validation of? Yeah. But without ENSO, what would you need to do to achieve this? Yeah, as a user. So think of yourself as a DeFi user. You would need to bridge. So to bridge, how would your process look like? Go to the bridge, connect the wallet, but which bridge? Sorry? Yeah. So there is a little bit of thinking that people need to do there. And I jumped straight into code. We'll come back to the UI later. But let's see how to do that with code. So this would be get route data. And in here, I need to pass an object, and this is pretty much what we need to pass. So there's amount in, and let's make it this much. The chain in, so we said base, so that's BASE. Destination chain ID, we want it to be on Bera. Now I need to copy this one because I don't know it by heart. There we go. And the from address, well, we need some sort of address. I'll copy one later. What we also need is token in, and that's our USDC. Token out, Bera, and there's a couple more parameters that we need to specify. There are sensible defaults, so I'm not going to specify all of them. For example, yeah, we'll come back to that one. I want to make this as fast as possible. So let's just, to find a quick address to copy to, I will actually go to the examples here and just copy this one. This is Vitalik's address, so we can we can pretend we're him. And that's pretty much it. So I'll just say route is whatever we get from this response. And to see what's going on, let's do, I'll stringify it and make it humanly readable. If I'm not mistaken, this is enough for us to test it out. So I'm gonna do node index.js, and this should run it. Oh. All right, so we get an API error because I forgot that when you do cross-chain, then you need the receiver. So here I'm going to say, well, receiver, and let's do the same address on Berachain. That doesn't really matter. And it must be an Ethereum address. So now that when we run it, it does some stuff. There's a lot of hex over here. That's the bytecode that makes all of this possible. But here's the interesting part. So this will show you the route that is happening in there. So it does bridging via Stargate, and it's taking in, well, this is the original USDC and the native token, and the token out is USDC, right? And then when the bridging is complete, we also need to do a transformation of whatever we got on the output to the Bera token. So this is the thing that we didn't express in the intent. So here we just said, take token and transform it into Bera on Berachain, but there's also swapping that's happening after the asset gets bridged. We cool with that? We're not cool with that. Could you pass the mic, please? Oh, you got one.
I just, with the first bridge, you started with an ERC20, and if you're going to wind up with an ERC20 on the next chain, you're not going to have the gas to do the final swap when you land on the next chain. So what would you do, or what happens in that case?
Let me ask you, what do you think?
Well, I would think you have to swap first to native token, then bridge native token.
Yeah.
Then you have it. So I would expect to see swap first, followed by bridge.
Yeah.
Yeah.
Okay, let's check out what these tokens are exactly. So the 833, that's our USDC, and this is the native token that also goes to Stargate. And the token out is 549. Let's see what this is. So it is on Bera, and the address is exactly what I copied here. So it's a USDCE that we got after the bridging, which got swapped into Bera. Yeah. I'm slightly puzzled as well, to be honest.
So the Bera you're getting is the native one?
Sorry?
So the Bera that you're getting is the native token, the guest token?
Yes. Yeah, and this is executing on Bera, so.
Who's executing on the swap on Bera?
Who's executing the swap on Bera? So this is not explicit over here, so it's not naming a protocol. It's one of the DEXs that are registered with ENSO within the aggregators that we rely on. So we could find that out if we took this and actually simulated a transaction, so we would definitely see what's going on in there. That's the best I can give you now. Any other questions? Okay, so now that we saw that, let's see what's happening in the UI, because where's my first challenge? Here it is. So you remember from not there. Yeah, here we also mentioned there's happy path. So let's do the same thing visually. So here we're going to pick base, and we said USDC, right? So there it is, and we're going to take it to Bearer chain, and we want Bearer token, right? So now when I enter, let's say 10 USDC, what we have Stargate is bridging it to USDCE and then swapping into Bearer. So it's pretty much the same thing. This is giving you a visual indication. So even if you want to quickly check out how something would go, you can actually use this UI to achieve it. And of course, you can specify different slippage tolerance and stuff like that. So this will be the way easier part that doesn't require any coding, but it's not repeatable. It's a manual process. So if you want to do something repeatable or to create a UI like that, the route API that we just saw over here is pretty much all you need. Any questions?
So this UI part, it was pre-created, right?
This UI part is public. We created that, and it's also an open source thing. So some projects actually built it in their UIs. So it's a solution that you can just paste and include it in your interface. Yeah. Yes, absolutely. So this front end is calling all of those APIs that we saw in VS Code. There was a question?
Yeah, does Enso have stuff for getting all the user balances of tokens, or do you use some other service for that?
Yes. So the question was if Enso has something to get user balances. So I'll just delete this one and get balances. The only thing that you need to pass is, well, EOA address, and yeah, I deleted it. Let me come back and pick it up again. Not here. So in the examples over here, yeah, let's take this again, and let me come back here. So the EOA address would be this, and use EOA, I'll set it to true. And chain ID, let's say 1, so now when I run it, oh, but it didn't catch it. And let's just console log it, so JSON stringify balances null 2 to make it a pretty print. So the only thing we needed to do is give it the address, say that we want to use the EOA and the chain we want the balances from, and after a little while, there you have it. So you have like the complete information. What's the token? What's the amount? What are the decimals? What's the current price of the token? What's the name of the token? The symbol, and you also get like the logo URL. This is live, so these things happen. Any other questions? Okay. where were we? So we saw that. Now, what I think we have time for one more example and then some questions. So the second challenge would be to do a cross-chain zap. So we just saw a swap, but what if I just want to enter a particular pool on a different chain? So if I have 1 ETH on mainnet, how can I enter Curve's 3 crypto pool? And here's 3 crypto. I'm going to copy the address, and of course these are the underlying for that one. And for this, I'm going to start with the UI first. So here I'm going to say I'm on Ethereum, and I'll paste this address over here, and for some reason it doesn't pick it up. Let me select the protocol. Yeah, I am. Sorry, I got confused. We start with ETH. We want to get into the curve pool. So we're here, and the target token will be on base, will be Curve, and will be 3 crypto. And this is why it didn't pop up, because it's a different address. So now, when I do that and say 1 ETH, okay, let's try 10. And there we go. So it would bridge it, deposit into Wrap Native, and then deposit into the Curve DEX. And again, we can do this by hand, practically, with the Route API, or we can do something a little bit different with the Bundle API. So I don't plan to repeat writing the get route code again. I would like to do an example that actually uses those actions that I mentioned, because we paid a lot of attention to them. Let's see why. Let's switch over to something more challenging. Again, 3 crypto pool, but this time we have 3 tokens. How can we deposit them into that one? What would we need to do regularly to achieve this? So I have 10 DAI, 10 USDC, 10 USDT on mainnet, and I want to deposit into that 3 crypto pool on base. Yes. This is a discussion point, so everybody can, yeah.
Just approve 3 times and deposit 3 times, or you could approve just 1 and deposit, and I think it will buy some of the missing tokens from the pool.
That's a part of the solution, correct? But these tokens are on mainnet, and we want to put them in a base pool.
Right, they have to be bridged first of all.
3-time bridging, and then after that, 3 deposits, if you want to deposit all 3 of these. Or you want to do some swaps in between, or something like that. So if you have 3 tokens like this, the Happy Path widget actually doesn't work because it accepts only 1 token. So we would have to do something like using the bundling. So you might remember that I said you can pick a lot of different actions and put them as a sequence, as a bunch of Legos. And who came to the stand today, you saw that there were Legos over there. So there's something happening in there. And this, what pretty much does, okay, this is a stupid example, it's got only 1 action. But you can put a lot of these actions, and it transforms them into a single transaction that gets executed. So I've got 20 minutes to create a bundle. Let's see how that works. Get bundle data. And let me just rename this one and move this away. So what we need to start with, just a second, what's the first argument? I need my IntelliSense here. So the first argument are bundle parameters. So this is like the basic stuff. Chain ID we're starting from, that's base, did we say? The second thing is from address. I deleted it again. The third thing is routing strategy. Now, in this case, we didn't talk about this one. The routing strategy is actually super important because in some cases, when you use this router option, that means that you're signing with an EOA. So some things are not possible. If you're using delegate, that means you're signing with a smart wallet, so 7702, and that's what makes it possible to put borrow inside of this one, for example. So for some actions, you absolutely must use bundle and must use delegate as the routing strategy. So I'll just put that in there. And yeah, you can, there's also some other stuff that happens here. Receiver, I'm going to put it there just for as a placeholder. And now the second argument is actually an array of actions. So our first action would be to bridge, right? And what we need to do is pick a protocol. So this is Stargate because currently ENSO does bridging only via Stargate. The next step would be arguments for the bridging, and that's an object. And here we have the token in, receiver, primary address, destination chain, and so on and so on. Let me just think for a second if we need to start with bridging. Yes, we absolutely must. And given we have 15 minutes, I'm fairly confident I will not be able to hit all those all those parameters. So I will actually ask you guys, how would you like to use the following 15 minutes? Because I'm pretty sure you don't want to see me trying to nail JSON. Yeah. Go ahead.
Is it okay to start the questions from now?
Yeah, we can do the questions and we can solve them via code or docs or just verbally.
All right. It's fairly different from those examples. I'm wondering if ENSO can be used for like maybe less DeFi use cases, like maybe on-chain voting.
Set up a context around it. So how do you see it?
So basically having the same benefits as using all these Lego blocks to build a voting application. So personally, I work on at Kleros, so we are a voting protocol. But I could think of other voting protocols that could benefit from using ENSO, for example. So you could have build an application that submits proposals or creates questions. Possibly in a cross-chain manner, actually. I think that would be quite useful.
Okay, and how would that voting work? Like, I guess there would be a sequence that you want to automate as a single action for voting. What would that consist of?
Okay, that's quite Kleros specific, so I don't know if it's going to interest everyone here. In the case of Kleros, I could imagine a useful building block could be to create a question, a dispute. That requires some fees that are going to be used to reward the participants in that question, who will vote on that question. So there's a payment attached to the question. The question contains some metadata, and typically in the V1 it's on Ethereum or Gnosis chain. But we could imagine, an abstraction layer that allows other applications on any chain, maybe on Base, to send a dispute to be created on Arbitrum or Gnosis chain. That would be very cool to do this with ENSO, for example.
Yeah, and how do you represent disputes?
It's there's a JSON metadata that needs to be uploaded to IPFS, and then the IPFS CID is part of the parameters of the function.
Mm-hmm. So theoretically, I see that's possible as long as you have actions that are abstracting those mechanics that are happening in the voting.
Okay.
So it really depends how you represent disputes, how you represent votes, and if any of these actions can work with that. And these are highly DeFi specific, so I doubt that they're applicable.
Yeah.
But the cool thing that's happening is that we're planning to open source the repository with these standardizations, standards.
Yeah.
So people can actually register their own custom actions.
Okay.
And then you can actually use them as little Legos.
Awesome.
To make those chains of actions.
All right.
And automate those voting
So
systems.
it may be possible in the near future to maybe create a PR in that repository and to add like community contributed actions.
Yeah, that's the vision behind it,
Awesome.
to make it open for community to extend.
Okay.
As of deadlines, follow our Twitter. Okay, thank you for the question. Could you just grab the mic, please?
Can the API key be in front-end code, or is it meant to be kept secret in the back end and do things through that?
Ideally in the backend.
Okay.
Yeah. The thing with the API key, I mean, you are rate limited. There's no signing happening with that, and it only serves to identify your front end that's doing something. In case you have several front ends that represent your app, then you would need, well, to put it on the back end to tell apart which front end actually interacted with Enzo, if that's important for you.
Okay, cool.
Yeah. But again, there's no mutation that you do to the data within Enzo. So from that perspective, you might even keep it in the front end. But this is not the official advice.
Okay, cool.
So the bridge you were using in the example, is it a third-party bridge or your own?
Yes, so this is a Stargate bridge.
Mm-hmm.
And you might remember that when I was enthusiastic about doing it, I started with the Stargate protocol, the bridge action, and yeah, let's just take a quick look of how that looks. So you would set the destination chain token in, amount in. Somebody asked the question, can I have dynamic values in these bundles? Yes, you can. So you can say, use the output of call at 1, and this is the call 1. So you can actually pipe results of actions into subsequent actions.
Mm-hmm. And so the actual question I was going to ask, that was a pre-question. So I see a receiver there. Is it the receiver of the funds on the destination chain?
Yes.
So, and whose address is that?
Sorry, could you get a mic, please? Because this is live stream, so.
You can define it. So, like, let's say, for example, you have your own wallet, you build an application, and then that user wants to send the money to, like, another user, for example. So you can literally set this. You can set it to smart account, you can set it to an EOA, whatever you define.
And like, if I want to bundle actions and do some additional action after the bridging, it probably wouldn't be my EOA address, would it?
Yes, it is. So, well, it lands inside of the ENSO account, like the ENSO smart contract. Generally, you don't need to set that. You'll see, like, there's an option of, like, you don't need to set it. If you don't set it, it'll go into the ENSO smart contract, and then from there, you can decide what you want to do with it thereafter.
But if you're signing with an EOA?
Yeah, that's the point. Yeah. So, like, ENSO's got contracts applied on all these different chains. The funds will land inside of there. Whatever actions you have after will be, like, all done atomically as well. We don't control that account. It's just like a intermediary contract to be able to bundle all these calls together.
So I could potentially take a look at this smart contract to make sure that only the stuff that I specified can happen to those funds, right?
Yeah, exactly. I mean, once you make any request to Enzo, by the way, sorry for hijacking. If you want to cut me off, you can.
No,
Don't
go
worry.
for it.
Everything gets simulated twice. So once you make a request, we generate all the call data that you've requested to do all these actions. We run it on forks. So we run it on like replicas of those chains to make sure that it all passes self. So nothing should be executed without making sure that it would pass. So you can check that and run your own simulation if you wish. So you could use, we built an open source simulator called Temper that was used by Gnosis Wallet, Gnosis Pay, Gelato, Yearn, and Cowswap. All for free, all open source. You can run that on your site if you want.
Thank you.
Okay, thanks for the questions. Any other questions? All right. There is a question.
Yeah, by the way, really good job on the workshop. I like your pace and the overall presentation. I got a question which is not maybe very much directly specific to the workshop, but just generally, since Enzo looks to be like primarily focused on developers, and you're a developer at Enzo, so I was wondering what were and are the best practices for you, in attracting the mind share of developers, because we know, there's a bunch of infra right now, and the attention is very much scattered. Everybody's fighting for developers. So, what has been the most rewarding practices you guys are doing to attract, the adoption and the usage of Enzo?
It's a never-ending experimentation. I don't have the best answer for any problem.
But maybe there was something that you did that was like, okay, this worked.
Can I answer a bit?
Yeah.
We shipped 2 products ourselves. So we shipped a social trading product. We built a DeFi super app that built some recognition in the space. Then we realized all the problems that we have, everyone else does. And people reached out to us, my language said, how the fuck did you integrate 50 DeFi protocols in day one? We're like, you all have the same issue. Here, use our API. The other thing that we found, we're like the first mover advantage. 2 people are now copying us to do the exact same thing, which is really good for us. They think it's not, but it's really good because they reach out to get people to use their API. And everyone's like, oh, but Enzo does this. Enzo's been around for so long. So if you can somehow get people to become competitors, it actually benefits you indirectly. The other thing that we've done, sorry for hijacking again, is mini applications. So Vercel, we copied Vercel pretty much. The reason why Vercel took off so well was they built many products themselves and just open sourced it, right? Now people can go to that and be like, Jesus, this Enzo team, Nenad built it, Dimitri and our team built it kind of in a couple of days. But this is a whole product that people raise millions of dollars for, and they've just open sourced it. So this kind of 1 gives more ideas, and 2 gives more awareness of what you can build. And yeah, 1 is honestly hire a good BD as well. Before I was doing it myself, and then we hired a BD, and that's kind of you're part of every single conversation. But I think the biggest part was building products ourselves and showing how it can be used. Instead of a lot of these infra products are talking about what it can do, but nobody shows you what you can actually build with it. It's all theoretical and all words.
So this is the gallery of those products that we built, dog fooding our APIs and figuring out how to improve both the interface developers have to deal with and the way they work and how optimal they are. And I think that there was a couple of interactions with dev teams where they were like, it's already done. Like in 30 minutes, they would actually be able to integrate and go along. For some of these, the actual heavy lifting, the DeFi stuff was not that super hard. The super hard part was the UI. So that also speaks a lot. So my point of view is do a good developer experience and show devs the power of it. And that's pretty much what it boils down to from the DevRel perspective.
The other, sorry to hijack again, but, the other thing we notice is we just build stuff, right? Like some of our competitors, they just talk, blah, 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 blah. We just integrate the protocol. We send the protocol and be like, this is a really interesting thing. You know Privy got acquired, right? Yeah, the founder's really smart. If you get in a call with Privy, what he'll do is he will show you how to integrate Privy in your application on the call. We do the same. So we add your DeFi protocol before we even have a conversation. And we get in a call and we show you how it works. And that's like, you know, compared to other people that just say, hey, you could do this. We show you on like within the first 5 minutes and you're sold in 15 minutes straight away. Again, I'll leave it to you, sorry.
Thank you. This turned into a panel, which is also exciting. All right. All right, we got 2 minutes. Time for one more question. Oh, there's a couple of questions yet.
Technical one.
Yeah.
I'm just doing the Enzo get balances, but I'm not actually getting any balances and stuff.
Did you say? Connor will help. All right. Any? Yeah, go for it.
Could you please name 1 or 2 examples of the bundles which are most popular amongst your clients, and what types of entities these are? Is it like DEXs? Is it B2C users? Like?
Yeah. So the most popular ones, I didn't do the research, but looping is one that's mentioned fairly often. Also rebalancing as well. So when you go to the docs here in the build section, there's a shortcuts library. So there's this smart routing examples, and there's also the examples of stuff people use bundle for. So you get staking pipelines, you get leverage positions, which is looping essentially, you know, stuff like that. So you can explore what's in there. I don't know which one is the most popular, but you can get, you know, the sense of the most common ones and how to get started there. Okay, thank you for the question. It feels like, yeah, go for it.
I'm not familiar at all with the crypto economic side of how the network executes basically everything that we've seen in code. I've just saw that they are validators. So maybe from a defensive point of view, like how do I know that someone is going to execute according to my specifications those actions? How would I know? How would I know if someone actually doesn't? And what happens to them?
Yeah. All right, Connor. Please join the conversation.
So what you read about the validators is like the decentralized network. Only today we started phase 1 of the decentralization, so people can like add to the network. How do you know what we respond is gonna give you what you asked for? 1, we simulate it. 2, we give you all the call data. 3, we give you each step by step. And we open source our simulator. So you can run that yourself to double check, or you can plug into Tendril API, for example. The other method that we're doing whenever other validators come into play, because we're the only people right now, why we do that? 1, just faster to market, test idea, blah, blah, blah. They will have modules inside. There's like a shared library of, hey, I want to inspect this call data for any delegate calls happening, any approvals happening, any transfers to accounts that weren't asked inside of the request itself. So it's kind of like a checklist itself. I would say, to be honest, the safest way of doing this is simulate it on your side. Like, you can trust us because we've not lost any money so far. But again, you know, the back end being hijacked is a risk, right? But yeah, we simulate. You can run those simulations yourself. And we don't ever execute, by the way.
I just really as a
Yeah.
yeah. So you give me the cool data, then I need to make sure before I execute myself.
Yeah. I mean, a lot of people, we give you all the response data, they use that to present to the users. There's a bit of trust element inside there, but proof is inside the pudding. We're not going to take the funds, right? And you can check the step by step yourself.
Thank you.
All right, we're a bit over time. Nobody's kicking us out, but I think we should wrap it up. Thank you, everybody, for joining, and thank you for great questions. All right. That would be it. Before you leave, there's a bunch of T-shirts that